Hey guys, welcome to the channel. Get comfortable, loosen your brain, and let your imagination do the swimming because we're about to dive into the most ridiculous, unsettling, and awe-soaked facts the ocean has been hiding for millions of years. Close your eyes if you want. Just don't drift too far, because something with teeth probably already noticed you. The ocean doesn't care that humans name things. We call it Pacific, Atlantic, Indian, Arctic, and Southern, like we're organizing a closet. But all of it is one enormous body of water swallowing 71% of the planet. That alone should make you mildly uncomfortable. Land is just the temporary garnish on Earth's main course. And even though we like to pretend we're in charge, more than 80% of the ocean is still completely unexplored. That means you've seen more of your neighbor's sad Facebook posts than scientists have seen of the seafloor. The top layer, the sunlit zone, is barely a scratch. It only goes down about 200 meters, which is nothing when the ocean can reach 11,000 meters deep. If Earth were an apple, humans have looked at the skin and declared themselves experts in core dynamics. Right at the shoreline, things start getting weirder than most people realize. Sand isn't just tiny, broken rocks. A shocking amount of it used to be something alive. Coral skeletons, shells, starfish parts, and fish poop baked by time into the stuff you build sandcastles and emotional memories with. Every grain has a history, but none of it cares about your beach selfies. And the tides that push that sand around aren't random vibes of the sea. The moon is out there yanking billions of tons of water back and forth every single day like it's kneading dough. If the moon disappeared, coastlines would turn into mosquito-infested puddle graveyards and tidal ecosystems would implode. Waves are just wind throwing a tantrum across the water's surface. Some are gentle and roll like they're auditioning for meditation apps. Others grow into rogue waves that can tower over a 10-story building and swallow ships without leaving receipts. For centuries, sailors were called liars for talking about walls of water taller than lighthouses. Then satellites showed up and said, yeah, those monsters are real and they don't send warnings. Near coastlines, waves move sand, carve cliffs, and casually erase human property like it's backspacing a typo. We keep building beachfront homes anyway, the same way cats keep jumping off counters like gravity is optional. Even in shallow waters, the ocean holds more life than our brains can track. Coral reefs cover less than 1% of the seafloor, but they host about a quarter of all marine species. That's like cramming 1,000 roommates into a studio apartment and calling it harmony. Reefs are alive, by the way. Those colorful branches and brains and boulders are colonies of tiny animals called polyps building underwater skyscrapers out of calcium and cooperation. And while we stare at them through glass-bottom boats like tourists at a buffet, half the world's coral is already dying from warming water and acidification. Imagine your house melting because the neighbors kept leaving the heater on for 50 years. Seaweed, kelp forests, and seagrass meadows don't get the same hype. But they're the ocean's version of rainforests. Giant kelp can grow almost 2 feet a day, which means it's more productive before lunch than most people are in a week. These underwater jungles shelter fish, feed invertebrates, and absorb ridiculous amounts of carbon dioxide. Humans discovered this and said, cool, let's turn some into chips and skincare. Even the water everyone thinks is empty is crammed with microscopic life. Plankton runs the show. Phytoplankton make more than half the oxygen you're breathing right now, and zooplankton are basically tiny, drifting mouths eating their way through the food chain. Without plankton, humanity would tap out faster than a phone on 1% battery. Some of them even glow. Bioluminescence isn't just a deep-sea thing. Waves at the shore can flash neon blue at night when disturbed by dinoflagellates, little organisms that light up when stressed, like introverts at birthday dinners. Fish in the sunlit zone have evolved every possible shape, color, and coping mechanism. Some use camouflage so detailed they might as well be in witness protection. Others advertise themselves with colors so bright they look like someone told evolution about rave culture. Parrotfish bite chunks of coral, grind it in their guts, and poop out new sand. Clownfish live in sea anemones that would kill almost anything else, but they're immune because their mucus coats are like chemical invisibility cloaks. Seahorses are fish that swim like disappointed balloons, and the males get pregnant because nature likes plot twists. Turtles glide through the shallows like ancient wizards, some of them crossing entire oceans with a navigation system no human can fully explain. Dolphins patrol coastlines with brains so advanced they name each other with signature whistles and sometimes bully pufferfish just to get mildly high. Sharks, meanwhile, have existed for over 400 million years, which means they were swimming around before trees were even invented. Most sharks aren't dangerous, but that doesn't stop people from screaming whenever a fin emerges near their toes, like Poseidon personally filed a complaint. Then there are mangroves, trees that decided dirt was optional and moved into saltwater. Their roots look like something out of a fantasy swamp, but they stabilize shorelines, filter water, and serve as nurseries for fish, sharks, and crabs. Mangroves also store more carbon per area than tropical forests, but instead of thanking them, we keep cutting them down so beach resorts get better views. Even the noise in these shallow waters is absurd. Waves crash, shrimp snap their claws so loud they sound like bacon frying underwater, and fish literally grunt, croak, or drum with their swim bladders. Coral reefs hum like aquatic cities. You don't hear it while swimming because your ears are full of sunscreen and panic, but the ocean is never quiet. Sound travels over 4 times faster in water than air, and marine animals rely on it more than sight. Whales sing, dolphins click, fish gossip, shrimp commit sonic crimes. And yet, for all the chaos near the surface, this is the easiest, friendliest layer of the entire ocean. The sunlit zone is the kiddie pool compared to what waits even a little deeper. But before anyone plunges down there, the surface still has more secrets to cough up. The currents that swirl through it act like conveyor belts moving heat, nutrients, and entire ecosystems around the planet. The Gulf Stream alone carries more water every second than all the rivers on Earth combined. It's the reason Europe isn't a giant icicle, and every hurricane that ruins someone's vacation, born from warm ocean water that evaporates, spirals, and then decides land looks punchable. Even floating trash has formed its own kingdom. The Great Pacific Garbage Patch isn't an island you can stand on. It's a soup of plastic bits twice the size of Texas swirling in slow motion. Microplastics are now in fish guts, sea salt, and probably your bloodstream. Somewhere out there, a crab is living inside a bottle cap and judging us. The ocean near the surface looks calm in postcards, but it's a churning, pulsing, oxygen-making, coastline-devouring, species-breeding biome with more activity than most cities. And everything you've ever splashed around in, dived through, surfed on, or screamed near is only a thin, bright skin stretched over depths that make space look friendly. Just below the sunlit zone, light starts giving up. Around 200 meters down, the water slips into what scientists call the twilight zone, not because Rod Serling is lurking there, but because sunlight fades into a blue gloom and photosynthesis taps out completely. If you dropped your phone here, it would vanish faster than your motivation on a Monday morning. Yet this dim belt is home to the largest migration on Earth. One you never see and probably didn't know was happening every night while you're scrolling yourself to sleep. Millions of creatures rise from the dark depths under cover of darkness to feed in shallower water and then sink back down by dawn like spooky commuters on a silent train. The fish here are built for shadows. Many have giant eyes to catch the faintest flicker of light, while others gave up on eyeballs entirely and decided existence is easier when you don't have to look at anything. Lanternfish, bristlemouths, viperfish, hatchet fish. They sound made up, but they're real and thriving. Some have mouths too big for their bodies, some glow in patterns, and some are just teeth with fins. In fact, scientists estimate there are more bristle mouths than any other vertebrate on Earth, but you'll never see one at an aquarium gift shop because they live where your lungs would implode. The temperature drops like the ocean is personally offended by warmth, and pressure starts stacking on like debt collectors. For every 10 meters you descend, another atmosphere of pressure piles on your body. At 1,000 meters down, that's 100 times the pressure at the surface. Humans would pop like juice boxes, but fish down here shrug it off like it's Tuesday. Their bones are either reduced, flexible, or replaced with cartilage. Their flesh can be so gelatinous that if you brought them to the surface too fast, they'd collapse into a sad aquatic pudding. Most creatures in the twilight zone are masters of invisibility. Counter-shading is the trick. Dark on top, pale on the bottom, so predators above or below don't catch the outline. Some species evolved to reflect the exact shade of blue around them, like living mirrors. Others use bioluminescence to erase their shadows by lighting up their bellies to match the light from above. It's not dramatic like neon dolphins, just sneaky camouflage designed to not become someone's midnight snack. Then there are the light shows that actually look like alien tech. Creatures flash patterns to lure prey, communicate, or scream "back off" without using sound. Anglerfish don't show up just in cartoons. The females really do swim around with a glowing lure dangling from their forehead, like a nightlight attached to a murder weapon. The males, by comparison, are tiny parasites who bite the female and fuse into her body, becoming a permanent testicle attachment. Romantic, in a horrifying way. Squid also dominate these depths. Some have tentacles longer than your car. Others have eyeballs the size of dinner plates. The vampire squid sounds like an edgy band name, but it's real, though it doesn't suck blood. It drifts gently, trailing filaments that collect falling debris, then wraps itself in its own webbed arms when threatened, looking like a haunted umbrella. Its scientific name translates to vampire squid from hell, because taxonomists have a sense of drama. Even sharks lurk here, though not the ones people pose with on Instagram. The goblin shark looks like evolution quit halfway through its shift. With a long, flat snout and jaws that shoot forward like a spring-loaded trap, it's the jump scare of the fish world. The frilled shark hasn't updated its look in 80 million years and swims like a medieval eel that hates everyone. These creatures don't need good press. They're built for survival, not popularity contests. The food in the twilight zone is mostly marine snow, which sounds dainty but is really a blizzard of decomposing fish bits, poop particles, mucus, dead plankton, and anything else gravity claims. It drifts down constantly, feeding the hordes below. Without this disgusting confetti, the deep ocean would starve. Humans worry about dropping crumbs on the couch, but the entire seafloor is fed by falling crumbs of death and digestion. And while the twilight zone is gloomy, it still hears the surface's pulse. Some whales dive through here to hunt squid, diving for up to 90 minutes at a time. Imagine holding your breath that long while chasing calamari in the dark. Sperm whales can dive a mile deep and echolocate prey by blasting sound waves through the water like underwater bats with built-in subwoofers. Their clicks can be louder than a rocket launch, and their skulls are literal sound cannons. Most of the creatures in this layer are still mysteries. The majority of species down here haven't even been discovered. Scientists keep sending submersibles and cameras only to spot things with names like deep-sea spiky blob or elongated nope fish, because classification takes time and nightmares take priority. The ocean doesn't care that humans write documentaries. It's running a horror anthology no one asked for. Currents still thread through the gloom, carrying oxygen and nutrients from the surface to the deep and back. Some of these currents form underwater rivers that flow in channels carved into the seabed, complete with waterfalls, rapids, and bends. The largest of these underwater rivers moves more water than the Amazon. And because water is heavier when cold and salty, these rivers can sink under layers of warmer water like liquid snakes slithering silently through the dark. Occasionally, storms at the surface churn the layers hard enough to drag nutrients up, fueling plankton blooms that kickstart entire feeding frenzies. Everything in the ocean is connected by invisible conveyor belts of motion, temperature, and decay. Humans build borders, but the sea doesn't color inside any lines. And all of this, the glowing lures, the vertical migrations, the silent currents, still happens far above the truly dark part of the ocean. The twilight zone fades out around 1,000 meters, where sunlight gives its final resignation letter and darkness becomes permanent. But that next layer is waiting patiently, full of teeth, pressure, and animals that look like rejected mythological drafts. Once the last scraps of sunlight surrender, the ocean stops trying to look familiar. Below 1,000 meters, you enter the midnight zone, where light doesn't just fade, it ceases to exist. If you fell in at this depth, you wouldn't see your own hand, even if it smacked you in the face. The pressure stacks up like the universe is trying to fold you into a travel-sized version of yourself. Down here, it can reach hundreds of times what you experience at sea level, and the temperature hovers just above freezing. This is not water you swim in. This is water that crushes submarines and erases hubris. And yet, somehow, life still exists here, thriving like the rules never applied to it in the first place. Most creatures navigate with senses humans don't even have. Bioluminescence becomes the only light show in town, and around 90% of animals in this zone either glow or react to light in some way. It's less about aesthetics and more about survival. Flash to attract a mate, spark to lure prey, burst light to startle predators. Glow like a haunting mood lamp so nothing sneaks up on you. It's less Finding Nemo, more paranormal rave hosted by evolution. Gulper eels drift like nightmares in slow motion. Their jaws are absurdly oversized, unhinging like a snake that swallowed a garbage bag. When food is rare, you evolve a mouth that doesn't believe in portion control. Their bodies are long, whip-like, and flimsy, built less for speed and more for sudden lunging lunges into darkness. Some of them have bioluminescent tails. They wiggle like fishing lures, as if to say, "Hey, come investigate this glowing worm so I can eat you with my face balloon." Then you get the fangtooth, a fish so small it could fit in your backpack, but so full of teeth it looks like a cursed keychain forged in anxiety. Its teeth are so large it has sockets in its skull just to store them when it closes its mouth. Even sharks look at it and think, that's aggressive. It can live more than 5,000 meters down, which is 5 kilometers of ocean crushing everything above it like a hydraulic press made of water. The pressure changes how biology works. Bones get minimal or disappear entirely. Organs evolve to withstand squeezing forces that would liquefy a human. And gas-filled swim bladders vanish because they'd implode instantly. Instead, many species fill their bodies with specialized oils and jelly-like tissue so they don't turn into sentient pancakes. You don't waste energy swimming fast, because down here, food isn't just scarce, it's mythical. You drift, you wait, you pounce when something dumb enough crosses your path. Squids in the midnight zone take strange to Olympic levels. The colossal squid, which people used to think was sailor exaggeration, has eyes the size of dinner plates, literally the largest eyes of any animal on Earth. It uses them to detect the faintest trace of movement in the abyss. And its tentacles aren't dainty noodles. They're armed with rotating hooks that don't just hold prey, they shred it. Scientists know they exist because sperm whales come to the surface covered in sucker scars the size of dinner plates, like they lost a bar fight against a sentient ceiling fan. There's also the stoplight loosejaw, a fish that fires out red bioluminescent beams nobody else can see because most deep-sea animals are blind to red light. It's basically using night vision goggles underwater to hunt in stealth mode. Its lower jaw is attached by hinges so thin the rest of its skull stays out of the way when it strikes, like a skeletal trap on a spring. Everything about the midnight zone shouts energy conservation. Many creatures are transparent, black or red. Since red light doesn't travel this deep, red animals might as well be wearing invisibility cloaks. Some species hold their breath for hours between meals that are more accidents than hunts. Many will eat anything, even things bigger than themselves, because in the deep you don't say no to calories. And sometimes the abyss gives you scenes straight out of cryptid documentaries. Giant isopods roam the seafloor like armored Roombas with depression issues. They look like pill bugs the size of house cats, scuttling across mud plains and scavenging anything unlucky enough to die and sink. If a whale carcass drops to the bottom, it triggers a full-scale buffet. Sharks, eels, crustaceans, worms, snails. They all converge like it's Black Friday for corpse meat. A single whale fall can feed entire ecosystems for decades. The bones themselves get colonized by worms that don't have mouths or stomachs, and instead use bacteria to digest fats locked in the bone. Those worms are called zombie worms, not metaphorically, literally. Sound also changes down here. Whales dive into the darkness and communicate across hundreds of miles with low-frequency calls. Submarines hide in what's called the SOFAR channel, a zone where sound gets trapped and travels ridiculous distances like gossip on Wi-Fi. You could drop a wrench into the deep, and a pod of whales 300 miles away might hear it and judge you. And no matter how alone the abyss feels, microscopic life never checks out. Bacteria thrive in sediment and on sinking particles. Tiny crustaceans dart around like aquatic bugs. Jellyfish drift by, some as small as your fingernail, others with tentacles longer than skyscrapers, are tall. The lion's mane jellyfish, for example, can reach over 100 feet in tentacle length. That's longer than blue whales, and they drift like haunted silk curtains waiting to ruin someone's week. Cameras sent down here keep catching things no one can identify. Creatures with transparent heads, tendrils like haunted chandeliers, or shapes that move wrong, like shadows trying to remember how physics works. Every expedition finds something new, which is a poetic way of saying we have no clue what's living under our feet right now. And yet, everything this deep still relies on the surface in some way, whether through falling debris, migrating prey, or currents funneling nutrients through liquid darkness. The midnight zone is a graveyard and a galaxy at the same time. Silent, freezing, and alive with things that don't care if you believe in them. There's a point in the ocean where pressure stops feeling like a force and starts feeling like a law. Past 3,000 meters, the abyssal zone takes over, an endless stretch of plains, trenches, seafloor mountains, and silence thick enough to rattle your nerves if you could hear anything at all. Down here, temperatures hover just above freezing, and the pressure can exceed 600 atmospheres. A human body wouldn't sink gracefully. It would compress, break, and disappear into darkness before panic even finished forming. The brittle stars crawl across the sediment in slow motion, like alien spiders designed by sleep paralysis. Sea cucumbers inflate and deflate like stress toys with digestive systems. Some look like floating jelly bags with legs, others like rubber balloons creeping across mud, absorbing whatever organic grime they can find. They don't have the luxury of options. Down here, food is a rumor carried on currents. Anglerfish still roam this deep, but they're not the only predators with built-in glow sticks. Dragonfish wield lights along their sides like runway indicators, and their teeth are clear to keep them from reflecting light and giving away their position. They don't just bite prey. They seize it in silence and swallow it whole, because teeth and patience beat speed and sunlight any day. The tripod fish perches on the seafloor using elongated fins like stilts, facing into the current with dead eyes, waiting for dinner to drift directly into its mouth. It looks like something that evolved out of boredom and stubborn refusal to move. Then you have rat-tail fish, long, thin, ghost-pale predators with oversized heads and tapering bodies that fade into the dark. They feed on worms, crustaceans, and anything soft enough to slurp. Hydrothermal vents puncture the abyss like hell's air conditioners suddenly installed upside down. They erupt superheated, mineral-rich water, sometimes over 400 degrees Celsius, into the freezing black around them. Instead of killing everything, these vents create entire ecosystems powered not by the sun, but by chemosynthesis. Bacteria feast on hydrogen sulfide, then become the foundation for tube worms, clams, crabs, and shrimp that treat vent chimneys like waterfront real estate. Some tube worms grow taller than humans, blood-red plumes waving in the chemical soup, all without mouths, stomachs, or eyes. They rely entirely on their internal symbiotic bacteria, which is either extremely clever biology or the ocean's version of trusting a roommate with your entire existence. Gigantic amphipods and vent crabs crawl over black smokers, towering mineral chimneys that look like underwater factory stacks exhaling darkness. These structures can reach heights rivaling buildings, only to collapse and rebuild in geological cycles. The chemistry here is so intense that metal deposits form in layers, and scientists study them the way people once stared at volcanoes and thought gods were angry. Life that isn't tied to vents adapts by becoming patient, durable, and terrifyingly opportunistic. Dumbo octopuses flap their ear-like fins as they drift through the gloom, looking like underwater ghosts with good manners. They don't ink because there's no point. There's no light to hide in, and nobody down here is impressed by dramatic exits. Worms dominate the abyss in shapes and forms unfit for bedtime stories. Some launch sticky threads into the water to catch falling particles. Others burrow into whale bones or sediment, digesting the deep sea the way termites hollow out wood. Bristle worms flash colors when disturbed, not because they want attention, but because warning signals work even when no one's watching. The seafloor isn't flat either. Mid-ocean ridges stretch thousands of miles like scars where tectonic plates pull apart. Trenches plunge deeper than Everest is tall. The Mariana Trench sinks nearly 11,000 meters down into a pit so crushing and isolated it might as well be another planet. The pressure at the bottom would turn a human submarine into scrap, if not engineered with absurd precision. Yet bacteria, amphipods, and snailfish live there like it's just another Tuesday. Snailfish in the Hadal trenches look almost translucent, with bones so soft they'd disintegrate at the surface. They feed on amphipods that are themselves surprisingly thick and muscular for creatures living in eternal darkness. Their cells contain unique proteins that stabilize their structure against crushing pressure, biochemical armor forged by millions of years of necessity. The deeper you go, the more reality bends. Jelly-like creatures float past like thoughts. Some have trailing filaments long enough to wrap a house. Others pulse slowly like haunted lanterns made of meat and moonlight. Entire species disappear and reappear between expeditions, hiding in trenches and canyons nobody has mapped. The ocean floor is more alien than Mars, and yet it's right beneath the same water people splash around in at beach resorts. Even underwater landslides reshape the terrain without a whisper. Turbidity currents can carve canyons and bury valleys in clouds of silt, moving faster than cars on highways. These silty avalanches can snap undersea cables and wipe out entire benthic communities in minutes. And no one on the surface notices. maybe a blip on an instrument, a puzzled researcher, then back to pretending the ocean is predictable. And somehow, through the cold, the dark and the silence, existence thrives. Not spectacularly, not elegantly, but persistently, and with adaptations that make human inventions look like foam toys. Down here, life doesn't fight the void. It becomes part of it, filling every crevice and drop like the ocean itself. For all the horrors and hallucinations the deep serves up, it still isn't done showing off. The ocean floor is not the flat cartoon desert people imagine under the waves. Mountains taller than anything on land rise from the abyss. If you drained the oceans, Earth would look like a stitched-together monster of canyons, volcanoes, ridges, cliffs and trenches stacked like broken tectonic puzzle pieces. The Mid-Atlantic Ridge alone is the longest mountain range on the planet, over 60,000 kilometers long. Yet nobody takes selfies there because it's buried under kilometers of nightmare water and darkness. Earthquakes happen down here constantly. When tectonic plates grind, shift and snap, the ocean doesn't ask permission before throwing a tantrum. Tsunamis are born in seconds, racing across thousands of miles faster than commercial jets. On the seafloor, fissures open, magma spills, and new crust forms while shrimp and bacteria loiter like it's background noise. Volcanic eruptions under the sea outnumber the ones on land, but humans only notice the rare ones that burp lava high enough to stain the sky or spawn islands out of nowhere like magic tricks with consequences. Then there are methane seeps and cold seeps scattered like deep-sea oddities, places where methane and hydrogen sulfide leak from the crust and give rise to ecosystems powered by chemical energy instead of light. At these seeps, clams, mussels and tube worms crowd the mud like squatters around invisible campfires. Some crabs carry symbiotic bacteria on their claws and wave them through the water like they're farming tiny invisible crops. Humans discovered this and immediately started thinking about energy extraction while nature just kept being weird. Ocean trenches carve scars across the planet that hold secrets older than recorded history. The Mariana Trench, Tonga Trench, Kermadec Trench, they form a chain of pressure cookers where the crust bends into oblivion. Even sound behaves differently here. Noise gets swallowed and stretched until silence sounds like a living thing. Only a handful of humans have ever been to these depths, and every expedition reports something no one expected, followed by unanswered questions. Scientists pretend they're not losing sleep over. The silt and sediment that blanket the abyss look empty, but hide entire universes of microscopic life. Foraminifera, tiny organisms with shells, leave behind layers so thick they shape continents when the planet recycles itself. Worms live inside the muck like silent miners, digesting particles older than civilizations. Crustaceans burrow into mud that hasn't seen light since dinosaurs were prototypes. Even abandoned shark teeth pile up like lost weapons scattered after battles no one witnessed. Shipwrecks litter the seafloor like the planet's junk drawer. Some sank hundreds of years ago and now host coral, sponges and fish squatting in what used to be luxury cabins. Wooden ships rot into the sediment while iron ones rust into skeletal ribs. Submarines sleep in silence, their metal hulls slowly surrendering to bacteria, salt and time. Planes, tanks, wartime debris and forgotten cargo containers rest so deep no one bothers trying to retrieve them. The ocean remembers everything humans drop, and it never cleans up. Canyons carved by ancient rivers stretch under the waves, relics from when sea levels were lower and coastlines sat miles away from where they are now. Some underwater canyons are bigger than the Grand Canyon, but they go unseen, mapped only by sonar and curiosity. Creatures glide through them like shadows in sunken cathedrals, drifting between walls taller than skyscrapers and older than bones. Even the flat-looking abyssal plains hide seamounts, underwater mountains rising thousands of meters from the floor. Some reach almost to the surface, but never break it, hiding just beneath the waves like giants crouched in silence. These seamounts host their own caste of creatures, many of which exist nowhere else on Earth. Deep-sea corals, sponges, fish and crustaceans cling to their slopes, while currents deliver food like conveyor belts from the surface. Thousands of these seamounts haven't even been studied or named. They exist in the dark, indifferent to whether humans ever acknowledge them. Sediment on the seafloor builds slowly, like the planet is sprinkling dust over its secrets. In some places, only a centimeter of sediment settles every 1,000 years. In others, rapid landslides bury everything in minutes and reshape the terrain like a toddler flipping a table. And in those layers, history gets trapped. Microplastics, volcanic ash, meteorite dust, whale bones, chemical traces, and the remains of things never discovered. Currents still touch the seafloor, not with the violence of waves, but with the slow persistence of time. Thermohaline circulation drags cold, dense water from the poles into the deep, then slides it across basins like liquid tectonics. These currents can take 1,000 years to complete their loop around the planet, moving nutrients, oxygen, and heat in silence beneath the chaos of storms and shorelines. Every now and then, a carcass falls from above, a tuna, a shark, a whale, and the deep responds like it was waiting. Hagfish slither in and melt flesh with slime. Crabs rip at tissue with claws built for patience, not speed. Worms appear as though conjured from the mud. Over months, bones are stripped, soft tissue vanishes, and bacteria finish the job. The deep recycles everything, even tragedy. And yet stories from the abyss are still fragments. Cameras break, submersibles crush, data vanishes into black water. Every discovery feels like a mistake the ocean allowed briefly before closing its hand around another secret. The surface world debates funding and policy while the planet's largest biome shrugs in silence, containing mysteries the rest of Earth can't survive long enough to witness. Even in the parts of the ocean where nothing should function, life still finds ways to mock logic. Some organisms don't just tolerate the deep. They thrive like the abyss was custom-built for their existence. Giant tube worms, vent crabs, snailfish, and amphipods aren't the limits of adaptation. They're just the visible examples. Most of what lives down here is so small, translucent, or slow that cameras miss them entirely. Microbes dominate the sediment, breaking down molecules that sunlight never touched. They metabolize hydrogen, sulfur, methane, and iron like they're eating gourmet meals while everything above them collapses from pressure. Deep-sea sponges live for hundreds or even thousands of years, rooted to rocks in silence, filtering bacteria and particles from water that barely moves. Some are older than modern civilizations, just existing on the planet's floor while humans above invent TikTok and argue about flat Earth theories. And coral, yes, coral, also grows in the abyss. Not the bright, shallow stuff people snorkel over while burning their backs in the sun, but pale, branching forests of slow-growing skeletons that spread across underwater mountains. Some deep-sea coral formations are older than the pyramids and reach heights comparable to multi-story buildings. They grow in waters so cold and dark that the idea of colour feels fictional. Crustaceans in the deep don't behave like the polite shrimp and crabs near the surface. Deep-sea amphipods can grow more than a foot long thanks to chemical conditions that supercharge their storage of energy. Some isopods inflate like armoured balloons and scavenge with the patience of monks. Others look like armoured worms with arms and antennae designed to feel rather than see. Their shells are often translucent, their muscles adapted to squeezing rather than sprinting, and their movements are calculated like every calorie is a gamble. Jellyfish rewrite physics in silence. Some use dangling tentacles to catch snow-like debris. Others pulse slowly upward with bells so thin they look like ghosts waving through water. The Stygiomedusa gigantea, nicknamed the giant phantom jelly, can stretch over 30 feet across, with arms that look like silk banners floating through orbit. It has no tentacles, only 4 thick trailing appendages it uses to trap prey in slow motion. Humans have seen it only a handful of times, and every sighting looks like someone accidentally filmed an underwater spirit. There are fish with antifreeze proteins in their blood to keep their insides from turning into slush. There are worms that build tubes out of sand, bones and volcanic sediment to hide from predators nobody has recorded yet. Some sea stars have 18 arms and crawl at speeds surprisingly fast for something shaped like a pancake with ambitions. Brittle stars cluster by the hundreds on rocks and seamounts, arms waving in currents like a field of alien sunflowers starved of sun. Even garbage thrown overboard by humans gets assimilated. A plastic bottle can sink into the abyss and become home to bacteria, barnacles, worms, and fish larvae. Lost fishing nets drift until they snag on underwater mountains and turn into ghost towns occupied by crustaceans. Microplastics get buried in sediment and eaten by organisms that don't know they're ingesting synthetic crumbs. Human waste is now part of the geologic record, and the deep accepts it the way it accepts bones, minerals, and ash. Chemistry itself warps in this realm. Carbon dioxide dissolves differently under pressure, forming pools and layers that behave like invisible fog. Methane hydrates, crystalline structures of gas and ice, form under the seafloor in amounts so massive that destabilizing them could shift entire climates. Some scientists believe that landslides in these layers could release methane in bursts powerful enough to alter the atmosphere, but they can't tell when or how, because studying that deep is like trying to read in a blackout with a matchstick. Even sound down here is strange. Some animals have lost the ability to hear entirely because silence is cheaper to maintain than awareness. Others use vibrations through sediment to sense motion, detecting worms tunneling dozens of meters away. Fish produce clicks, pulses, and hums no one expected, their body parts adapted as built-in speakers and receivers. But those sounds don't travel the way they do near the surface. Pressure and density stretch and scatter them, so conversations down here are short, local, and unsettlingly quiet. Then there are brine pools, underwater lakes inside the ocean that look like liquid portals to somewhere worse. These pools are so dense with salt they don't mix with surrounding water, forming shoreline-like edges and waves that lap against mudslopes. Anything that wanders in dies fast, suffocated or pickled in hypersaline fluid. Yet even at the edges of these toxic ponds, mussels, worms and bacteria line up like tenants waiting for chemical rent. Exploration of these depths is painfully limited. Submersibles can only stay down so long before batteries fail and metal starts thinking about folding. Remote-operated vehicles snap cables, lose cameras, and vanish into trenches with the same casual finality as socks disappearing in laundry. Every expedition is expensive, risky, and slow. But every time one returns, it brings video of something that looks too bizarre to be alive, prompting scientists to write papers that are basically polite ways of saying, "What was that?" Meanwhile, everything above these depths still benefits. Nutrient cycles rise slowly through the water column, powering plankton blooms near the surface that feed fish, whales, and eventually people. Deep currents regulate climate, distribute heat, and store carbon in ways no human technology can replicate. The darkest parts of the ocean are quietly holding the planet together, while the surface pretends it's in charge. For all the death, pressure, silence, and bone-crushing cold the deep dishes out, the ocean still finds ways to mock expectations. It doesn't stop at physical weirdness. It dabbles in behavior, strategy, and design choices that make the animal kingdom on land look like it evolved using crayons and guesswork. Even in the upper and mid layers, where creatures still see some light or remember what it was, the adaptations are so specific and unhinged that it feels like evolution speedrun a horror game with no tutorial. Take the mimic octopus. Instead of just camouflaging, it impersonates other animals like it's doing improv at the bottom of the sea. It flattens itself and swims like a flounder, stretches its arms and stripes to copy a venomous sea snake, or bunches up to look like a lionfish. This isn't accidental. It chooses the disguise based on whatever predator is nearby, essentially deciding what costume says, "Eat someone else." And that's just one octopus. Others collect shells and carry them like portable bunkers, while some detach their own arms to distract attackers, sending a flailing limb to do the panicking for them. Jellyfish, the ocean's floating USB errors, don't even pretend to follow rules. The immortal jellyfish, Turritopsis dohrnii, can revert to its younger form when threatened or damaged, basically Benjamin buttoning itself into immortality. It doesn't die of old age. It just restarts the game whenever it feels like it. Meanwhile, box jellyfish are armed with venom so strong it can stop a human heart in minutes, and their tentacles can reach 10 feet long. They don't chase you. You just accidentally brush up against one and your nervous system files for retirement. Sea cucumbers, the squishy vacuum cleaners of the seafloor, defend themselves by ejecting their internal organs out of their butts like grotesque party streamers. Predators get distracted trying to figure out what just happened while the cucumber crawls away and regrows its guts like it didn't just turn itself into a biology pop-up book. Starfish can regrow entire arms, and in some cases, an arm can regrow an entire starfish if it contains part of the central disc. That's right. A severed limb can become a whole new animal like it's photocopying itself out of spite. Clownfish aren't just orange dopamine, they're born male, but the largest fish in the group becomes female as needed. If the breeding female dies, the dominant male changes sex and takes over while the others stay in line like polite gender-fluid backup dancers. Moray eels have a second set of jaws inside their throats, like a xenomorph from Alien, that shoot forward to drag prey into the digestive void. They don't chew, they don't bite twice. They just grab and vanish your existence into a tube of teeth. Then there's the mantis shrimp, nature's rage-powered jackhammer. Their punches are so fast, they boil the water around their claws and create shockwaves that can break aquarium glass. Their eyes see more colors than humans can even conceptualize, including ultraviolet and polarized light. You can't sneak up on something that's basically running the IMAX version of reality in its head, while carrying the ability to crack skulls with a tap. Parrotfish sleep in mucus cocoons. They spit around their bodies like personal hazmat bubbles to mask their scent from predators. That slime sack is the only reason moray eels don't snack on them at night. Wrasses change not just their sex, but their behavior, coloration, and dominance hierarchy depending on who dies or disappears. Cleaner wrasses run fish spas, picking parasites off larger animals who patiently line up like customers at a dermatology clinic. Some imposter wrasses fake the uniform, get close, then rip out chunks of flesh and flee before the Yelp reviews pile up. Shrimp snap their claws so fast the sound can stun prey and shatter shells. Some squirt bioluminescent goo as a smokescreen to escape threats. Crabs use anemones as living boxing gloves, holding them in their claws so anything dumb enough to attack them gets stung in the face. They literally wield living weapons like medieval sea goblins. Even the eyeballs get weird. Flatfish are born normal. Then one eye migrates across their skull as they mature, so both eyes end up on the same side. They lie on the seafloor, half-buried, glaring upward like disgruntled rugs, waiting to inhale something edible. Seahorses drift vertically because they don't care about how fish are supposed to swim, and the males carry the babies because the ocean doesn't care about your expectations. Meanwhile, the Portuguese man-o'-war isn't even one animal. It's a floating colony made of specialized organisms fused together. One part handles stinging, another digestion, another reproduction, another buoyancy. It's 4 creatures in a trench coat pretending to be one monster. And humans keep thinking it's a jellyfish because the ocean loves letting us be wrong. Every inch of the water column is a manifesto of biological disrespect for normality. The closer you look, the more the rules fray at the edges until you realize the ocean never followed the same rule book as everything on land. Up here, near here, or far below, nothing is behaving in a way that should make you comfortable. The ocean doesn't just bend biology, it rewrites physics for fun. Animals have learned to manipulate light, pressure, sound, electricity and chemistry in ways that feel like superpowers disguised as survival tactics. Even the ones that look harmless would be considered warlocks if they lived on land. Take electric rays and electric eels. Yes, they're mostly in freshwater, but their oceanic cousins pack enough voltage to drop predators like unplugging a toaster mid-toast. These animals have electric organs built from modified muscle cells, stacked like batteries inside their bodies. They can sense electromagnetic fields too, using that ability to navigate dark waters or locate buried prey like living metal detectors. Sharks take that concept even further. They're equipped with ampullae of Lorenzini, tiny gel-filled pores that detect electrical impulses from the muscles and hearts of nearby animals. A fish could be hiding under sand, frozen in fear, and a shark would still clock its heartbeat like it subscribed to its pulse. Some sharks bump into submarine cables because they mistake the artificial current for prey signals. They don't bite boats because they're evil. They just think electronics taste like opportunity. Sound is another tool the ocean bends into advantage. Snapping shrimp form colonies where their collective pops create noise so intense it drowns out submarines and sonar equipment. Dolphins use echolocation so precisely they can detect a fish's organs through murky water like underwater radiologists. Sperm whales produce clicks loud enough to vibrate your bones apart if you were too close. Their skulls are basically organic amplifiers filled with wax and oil that shape sound into a weapon and a language. Some fish generate light internally, storing bioluminescent chemicals in organs called photophores. Flashlight fish use these to signal in patterns like underwater Morse code. Cookie-cutter sharks use glowing undersides to mimic the silhouettes of smaller fish so predators ignore them, until they latch onto whales, submarines, and even fiber optic cables, carving circular plugs of flesh or material like deep-sea hole punchers. Scientists have found bite marks from them on submarines and torpedoes because the ocean thinks everything is edible until proven otherwise. Squid communicate with color changes, pulsing pigment cells called chromatophores that let their skin flicker like malfunctioning billboards. They can hypnotize prey with swirling displays or confuse predators with flashes that look like distress signals. Cuttlefish are even more theatrical. Some can change not only color, but texture, mimicking coral, sand, or rock at will. They don't hide from danger, they cosplay as it. Even invisibility is on the table. Glass squid and glass eels are nearly transparent, their organs centralized or minimized so light passes through them instead of reflecting. Some deep-sea jellies go a step further and scatter light across their bodies to break up outlines entirely, vanishing into darkness like ghosts with bad intentions. Others create glowing ink clouds that work like underwater flashbangs, distracting predators while they slip away. Then there are creatures that don't swim so much as drift with structural audacity. The salp, a gelatinous creature that floats in chains longer than school buses, filters plankton with quiet efficiency while looking like someone forgot to finish designing it. Pyrosomes, tube-shaped colonies of thousands of clone organisms, can stretch over 60 feet long and emit a soft bioluminescent glow when disturbed. They drift like haunted sleeping bags made of tissue and teamwork. And while all of this is happening, the water itself is constantly shaping and moving life in ways that make weather look like mood swings. Currents carry larvae across oceans to places their parents never visited. Upwelling zones drag nutrients from the deep toward the surface, feeding plankton blooms that explode into feeding frenzies. Hurricanes suck warm surface water into their spirals and leave cold trails behind them like atmospheric vandalism. When a storm passes, the ocean doesn't complain. It shrugs, redistributes heat, and continues the slow rotation of currents humans still don't fully understand. Marine snow, the constant fall of mucus-coated fecal particles, dead plankton and biological leftovers, feeds not only the deep but mid-water creatures that rise and fall with the dusk and dawn. This vertical migration, the largest on Earth, happens every night, with billions of animals moving up toward the surface to feed under the safety of darkness before sinking again with the sunrise. They do this regardless of what humans are doing above. War, peace, elections, TikTok trends, it's irrelevant. The ocean keeps its schedule. And while you picture fish and squid and glowing nightmares drifting, you forget the single-celled architects ruling everything. Plankton produce at least half of all breathable oxygen on Earth. Without them, civilization wouldn't have time to panic before collapsing. Krill swarm in clouds so dense they're visible from space, feeding whales that migrate thousands of miles with no landmarks, GPS, or emotional support. Blue whales, the largest animals to ever live, dive and surface through layers of life like it's just commuting. Everything is linked by chaos that looks like order only because humans like to pretend they understand it. The ocean isn't a place, it's a system. Chemical, thermal, biological and violent on timelines, too big and too small to measure with calendars or patience. Everything living in it is shaped by millions of years of silent pressure and a constant gamble with death. For all the living nightmares drifting through the water, the ocean itself is just as unhinged. It doesn't behave like a simple bowl of water. It acts like a breathing, circulating, planet-sized engine running on moonlight, temperature swings, and chaos. The tides alone drag trillions of tons of water back and forth every day, like the moon is playing tug-of-war with Earth's arteries. Some coastlines rise and fall by over 50 feet because gravity doesn't care about beachfront property or romantic sunset dinners. If the moon were even slightly closer, the tides would bulldoze shorelines and erase entire cities with a twice-daily rinse cycle. Waves don't just crash for ambience. They're wind tantrums gaining strength over miles of open ocean, stacking on themselves until they break with enough force to snap bones, roll boulders, and toss ships like plastic toys. The biggest waves aren't even the ones you see. Rogue waves can rise taller than buildings and appear out of nowhere, hitting vessels with the precision of a cosmic punch. Sailors used to get laughed at for telling stories about 100-foot walls of water until satellites confirmed they were underestimating them. Beneath the surface, the ocean moves like a giant bloodstream. Currents carry heat across the globe, deciding which continents get snow and which get wine country. The Gulf Stream alone shoves more water per second than every river on Earth combined. If it ever slows or shifts, as scientists keep warning it could, Europe could snap freeze while the tropics boil like soup. These currents aren't guesswork. They're ocean conveyor belts moving heat, oxygen, and nutrients across distances so huge they make continents look like accidental decorations. The thermohaline circulation, a global loop driven by temperature and salinity, takes about 1,000 years to complete one cycle. A drop of water near Greenland can sink, slide along the seafloor past Africa, rise near Antarctica, get swept into the Pacific, and eventually return to the surface like it just completed the slowest victory lap in history. This quiet circulation stores carbon, supports ecosystems, and buffers the planet against climate swings humans keep accelerating like toddlers with matches. Then there's El Niño and La Niña, the ocean's mood swings that trigger droughts, floods, heat waves and storms across the globe. When warm water piles up in the Pacific, air currents warp, jet streams get drunk, and farmers, fishermen and governments panic while pretending it's fine. Meanwhile, plankton blooms shift, coral reefs bleach, and fish migration routes scramble like someone rearranged the entire planet's roadmap overnight. Storms don't form in the sky. They're born in the water. Hurricanes feed on warm ocean temperatures, growing stronger as they inhale heat and moisture, spinning into monstrosities that flatten coastlines and remind everyone the planet doesn't negotiate. Underwater currents drag these storms' leftovers into the deep, cooling the surface and redistributing nutrients like the ocean is cleaning up the mess it helped make. And while people picture the sea as a surface thing, surfboards, dolphins, cruise ships, the majority of its motion happens underwater, invisible. Subsurface eddies the size of cities form and dissolve like liquid whirlpools. Internal waves roll along density layers in the deep, taller than skyscrapers, completely unnoticed by satellites or swimmers. Some of these internal waves break against underwater mountains and trenches, stirring nutrients into circulation like an invisible kitchen blender. The ocean even creates its own weather. Sea spray injects salt and organic particles into the air, seeding clouds that drift over continents and drop rain on people who have no idea their storm started because of a wave thousands of miles away. Phytoplankton release sulfur compounds that rise into the atmosphere and help form more clouds, indirectly affecting temperature, rainfall, and sunlight. Microscopic life in the water literally helps decide how hot your afternoon is. Then there are upwellings, where deep, cold, nutrient-rich water rises toward the surface and triggers explosions of life so dramatic they reshape fisheries and food chains overnight. Coastal regions fueled by upwelling zones feed billions of people, even though these processes are controlled by winds, currents, and underwater topography most humans wouldn't recognize on a map. And it's not just horizontal movement. The ocean breathes vertically. Every night, trillions of creatures rise from the deep to feed near the surface in the largest migration on Earth, then sink again at dawn like a synchronized, silent elevator of hunger and fear. The movement of their bodies stirs water and carries nutrients with the same impact as storms and currents. Tiny animals, krill, shrimp, larvae, squid, do more for the ocean's balance than most nations do for their own infrastructure. All the while, the surface acts like nothing is happening. Sunlight glitters, waves shimmer, boats glide, and the real machinery of the planet churns below in darkness and silence, powered by ancient mechanics and biological persistence. The ocean doesn't brag. It just keeps the world running while everyone pretends land is the main event. Even when the ocean looks like it's sitting still, it's busy rerouting energy, sculpting coastlines, and quietly wrecking anything that assumes it's predictable. The surface is just the mask. Beneath it, currents and chemistry keep rewriting the script of the planet in real time. Upwellings spark population booms that feed entire ecosystems, and just as easily, changing winds can shut them down and starve regions into collapse. Fisheries that seemed endless a generation ago have been wiped to memory because the ocean doesn't restock shelves for convenience. Where continents meet the sea, there's a war zone disguised as scenery. Waves attack cliffs with slow brutality, turning rock into sand grain by grain. Sea stacks, arches, caves, and overhangs all start as stubborn landmasses that the tide eventually chews through like a patient animal. Whole towns have disappeared over decades as shorelines erode and beaches retreat. Some coastlines gain land from deposition just as fast, especially near deltas where rivers dump sediment faster than the sea can steal it. But even those get swept away when storms reroute everything in one night. Tsunamis don't need drama to form. An earthquake, an underwater landslide, a volcanic blast. Anything that shoves a chunk of seawater can give birth to a wave traveling hundreds of miles an hour. In the deep ocean, tsunamis barely rise a foot high, but when they reach shallow ground, they climb into walls that erase coastlines like typos. Some have crossed entire oceans before striking land on the opposite side of the world, leaving people with minutes or no warning at all. Submarine canyons, cut by ancient rivers back when sea levels were lower, now serve as underwater highways for sediments and creatures alike. Turbidity currents race through these trenches at speeds faster than cars, carrying sand, silt, gravel, and whatever unfortunate organisms lie in their path. These underwater avalanches can snap cables, bury habitats, and reshape miles of seafloor in a single event that no one on land ever feels. Even the chemistry of seawater decides the fate of life. Salinity shifts affect everything from buoyancy to breeding. Tiny changes in pH dissolve shells, silence reefs, and disrupt plankton that form the base of the food chain. Acidification from absorbed atmospheric carbon dioxide is already eating away at coral and weakening organisms that rely on calcium carbonate structures. The ocean has absorbed about a third of the carbon dioxide humans have released since the Industrial Revolution, acting like a planetary shock absorber. But shock absorbers aren't immortal. They just delay the crash. Temperature layers stack the ocean like a lasagna of moods. Warm water sits on top because it's lighter, locking colder, nutrient-rich water below. When storms or winds mix those layers, life explodes. When they don't, whole regions starve. Marine heat waves now appear so often that coral bleaching, once rare, is turning tropical reefs into ghost suburbs of brittle skeletons. Kelp forests bake in shallow coasts when temperatures spike just a few degrees above normal. The ocean doesn't need to boil to kill, just warm up slightly and wait. Gas exchange between air and sea looks calm, but it's brutal chemistry. Oxygen dissolves into surface water and gets carried down by currents, or not. Dead zones form in coastal regions where agricultural runoff fuels algae blooms that choke oxygen out of the water when they decompose. Fish flee if they can. Everything else suffocates quietly. In the Gulf of Mexico, one of these zones grows every year like a seasonal crime scene caused by fertilizer and denial. Storm surges shove seawater inland with the force of liquid bulldozers. Salt water seeps into soil and aquifers, killing crops and tainting freshwater supplies before receding like nothing happened. Mangroves, marshes, and seagrass beds act like biological armor, absorbing impact and trapping sediment. But humanity keeps tearing them out for tourism, harbors, and view property. The places most protected naturally are often those most dismantled by human stubbornness. Even the color of the ocean isn't consistent. Phytoplankton blooms can turn water green, red, brown, or milky blue. Some of these blooms feed everything above them. Others produce toxins strong enough to paralyze or kill fish, birds, mammals, and occasionally clueless swimmers. Red tides don't care about beach schedules or local economies. They shut down fisheries, poison whales, and blanket coastlines in dead fish like the world's worst welcome mat. And everything humans dump in the sea takes the grand tour. Oil spills don't vanish. They break apart, sink, coat shores, or dissolve into toxins that linger for decades. Plastic doesn't disappear either. It breaks into smaller and smaller pieces until plankton, fish, turtles, seabirds, and whales ingest them, mistaking colorful trash for food. Those pieces move up the food chain and eventually come back to humans on dinner plates disguised as protein with a side of polyethylene. Yet for all of this movement and mayhem, the ocean is still the reason the planet isn't cooking itself into dust. It absorbs more than 90% of the excess heat trapped by greenhouse gases, preventing continents from turning into scorched wastelands. But that stored heat doesn't vanish. It builds, changing currents, melting ice caps, and reshaping coastlines in increments that feel too slow until suddenly they don't. The ocean hasn't just shaped coastlines and weather, it's been rewriting history since before history existed. Long before humans learned how to ruin things on purpose, entire civilizations rose and vanished because the sea decided to move a few feet. The Earth has gone through cycles of ice ages and warming periods, each one lowering or raising sea levels by hundreds of feet. During the last glacial maximum, sea levels were over 300 feet lower than today, exposing land bridges that let humans and animals migrate across continents like they were walking through free real estate. Places like Beringia connected Asia and North America, and the English Channel's seafloor was once a hunting ground, not a shipping lane. Now most of those ancient coastlines are underwater, buried beneath silt and darkness like forgotten neighborhoods. Entire human settlements sit submerged off the coasts of India, Japan, Egypt and the Mediterranean, lost when glacial meltwater flooded the world thousands of years ago. Archaeologists find tools, pottery and stone structures resting where waves now churn, proof that the ocean has been taking back land in quiet installments long before beachfront condos existed. Even myths trace back to rising water. Stories of floods and drowned cities show up in dozens of cultures because at some point, someone watched their world sink and tried to warn the future with a story instead of a memo. Whether it was Atlantis or Doggerland or the Gulf of Kambat, the ocean has erased more history than humans have written. And the process hasn't stopped. Sea levels today are rising faster than at any time in recorded memory. Only this time, the water is coming for skyscrapers and suburbs instead of stone huts and fishing camps. Continents themselves owe their existence to the ocean. Before there were islands and landmasses, Earth was a molten sphere collecting water vapor and cosmic debris. As the planet cooled, tectonic plates formed, and the first ocean filled the basins. Hydrothermal vents may have sparked the earliest life forms, organisms that used chemical energy instead of sunlight to build the first biological systems. These microbes didn't need land, oxygen, or approval. They multiplied in boiling mineral clouds and kick-started everything that evolved afterward. When photosynthetic bacteria showed up billions of years later, they released oxygen that transformed the atmosphere and poisoned most of the anaerobic life that came before them. That oxygen eventually hardened the sky with ozone and made land survivable. Coral reefs began forming hundreds of millions of years ago, acting as underwater fortresses that buffered coastlines and laid limestone foundations as thick as mountains. What people now call islands in many regions were once reefs that rose, died, and rose again across epochs. Ocean currents also sculpted continents indirectly by controlling climate. Warm currents like the Gulf Stream carried heat that allowed Europe to develop mild conditions ideal for agriculture and civilization. Without that current, much of the northern hemisphere would still resemble tundra, and human history would have unfolded in entirely different clusters. The monsoon systems that fed early civilizations in South Asia and Africa were driven by oceanic heat as well. Egypt's wealth wasn't just the Nile, it was the seasonal flooding shaped by ocean temperature and pressure patterns thousands of miles away. The ocean has buried secrets in plain sight. Trillions of fossils, minerals, and artifacts rest under the seafloor, preserved beneath layers of sediment thicker than cities. Whale bones from extinct species lie beside Stone Age tools and ancient shipwrecks. Some trenches hold meteorite fragments that never hit land, lodged deep in muck where no human has ever touched them. There are lakes of brine, calcium carbonate towers, sulfur chimneys, and silica spires rising from the dark like underwater ruins built by time instead of intention. And then there are underwater volcanoes, thousands of them, many still active, reshaping the planet's crust quietly. Entire island chains like Hawaii were built from eruptions that began miles under the sea. Some volcanoes erupt without ever breaking the surface, generating steam explosions, ash plumes and lava flows that solidify into seamounts waiting for another eruption to finish the job. Pillow lava forms when molten rock hits cold salt water, creating bulbous layers that look like stacked brains or melted sculptures. Even the sand on beaches is a geological obituary. Every grain is a record of erosion, crushed shells, dead coral, ground rock, or volcanic residue shaped by waves and time. On tropical beaches, much of the sand literally passed through the digestive system of parrotfish that chew coral like it's breakfast cereal and poop out sand by the pound. Some islands are built almost entirely from fish poop, and tourists lie on them tanning like that fact isn't aggressively hilarious. And humans, for all their stories and structures, haven't been here long enough to claim anything. The ocean was carving cliffs, drowning forests, building reefs, and steering evolution billions of years before the first primates stood up and complained about the rain. Land is temporary. Shorelines are suggestions. And everything humans build near the water is either future driftwood or future reef. If the ocean wrote the planet's rough draft, it also keeps editing it behind everyone's back. The coastlines humans treat like permanent real estate are just temporary edges in a long argument between water and rock. Barrier islands shift like sandbars with ambition. Some move miles over a few centuries, rolling inland grain by grain as waves and wind shove them around. Towns built on them crack, sink, and disappear, not because the sea is dramatic, but because it's following physics older than architecture. Estuaries, the mixing zones where rivers meet the ocean, are nurseries for fish, crustaceans, and birds, but they're also constantly changing shape. Sediment from rivers collides with tides and builds mudflats and marshes that rise, drown, or migrate depending on how much freshwater and saltwater argue that season. Mangroves creep along tropical coasts with tangled roots designed to trap sediment and slow erosion. Their forests can expand outward into shallow water, building land over centuries while also absorbing storm surges better than any seawall humans have ever built. Even rivers owe their shape to the ocean. The mouths of major river systems curve, branch, and swerve based on tides and sea levels that dictate how far inland saltwater pushes. In some places, salt fingers creep hundreds of miles upriver, changing water chemistry and reshaping what species can live there. Deltas form where sediment drops out, creating land that looks permanent until a storm or current rearranges it into a new outline. The Nile Delta, the Mississippi Delta, the Mekong Delta, all shrinking or shifting because upstream dams trap sediment and rising seas swallow the rest. Subduction zones, where oceanic plates dive beneath continents, recycle seafloor, and generate earthquakes and tsunamis in the process. The Pacific Ring of Fire is responsible for most of the planet's volcanic eruptions and some of its deadliest tremors, all thanks to ocean crust plunging into the mantle. That crust melts and fuels volcanoes that build islands, raise mountains, and occasionally erase coastal populations in one afternoon. Japan, New Zealand, the Aleutian Islands, the Andes, all born from oceanic plates colliding with continents and losing. Trenches mark the places where the seafloor is vanishing into Earth's interior. The oldest oceanic crust gets dragged down first, crumpling sediment and organisms into oblivion, while magma rises elsewhere to form new crust along mid-ocean ridges. The planet is eating and creating itself at the same time, and the ocean is the conveyor belt doing the work. Humans draw borders on maps like those lines won't snap in half during the next tectonic hiccup. Even islands made of coral skeletons, atolls and reef arcs are temporary whispers. They form when volcanic islands sink or erode, but coral keeps building upward toward the light, keeping pace with sea level until only a ring remains. Some of those rings are now slipping underwater faster than coral can keep up as temperatures rise and acidification weakens their structure. Entire nations like the Maldives, Kiribati and Tuvalu are watching their existence erased by inches of water and degrees of temperature. The ocean doesn't drown lands quickly. It dissolves them slowly while the world debates timelines. Storms leave signatures the land can't ignore. Tsunamis carve inland scars where forests, farms and roads stood hours before. Hurricanes chew coastlines and leave layers of sand and debris that geologists will read like diary entries centuries later. In some places, entire forests now stand offshore as drowned woodlands. You can see the trunks at low tide, still rooted in soil that used to be dry land thousands of years ago before rising seas reclaimed it. Even underwater, landscapes rise and fall. Seamounts that used to be islands are now hundreds of meters below the surface, topped with coral, sponges and fish that never knew they were living on a sunken volcano. Some of these drowned islands once hosted people and animals before sea levels swallowed them after the last ice age. Archaeologists keep finding stone tools and bones buried in offshore sediments where coastlines once existed. When glaciers melt, the water doesn't politely disperse. It seeps into every low-lying basin, pushes against shorelines, and seeps into porous rock. The weight of melted ice even changes the shape of continents. During the last deglaciation, places once crushed by ice sheets rebounded upward, while ocean basins deepened, redistributing water like a drunk god refilling a bowl. The process is still happening today. Some coastlines are rising, while others sink faster than tides can retreat. The ocean doesn't keep secrets out of malice. It just doesn't file reports for human benefit. Every inch of seafloor, from continental shelves to abyssal plains, tells a story in layers of sediment, bones, minerals, and drowned landforms no one alive has walked. But the surface world acts like history ends at the tide line, as if everything underwater is just background. Even with everything the ocean hides, people still pretend they know what's living in it because they've seen a few documentaries and a Pixar fish with memory issues. But marine life is so aggressively varied that you could spend your entire life studying it and still die ignorant of 90% of what's swimming, crawling, glowing, or absorbing nutrients in silence. The surface creatures are the relatable ones. The mascots, the celebrities, the PR team for an ecosystem that mostly doesn't care if you understand it. Dolphins aren't just smiling swimmers with beach ball energy. They're strategic hunters with social structures so advanced it's uncomfortable. They give each other names through signature whistles, teach their calves to use tools like sponges to protect their snouts while foraging, and bully sharks when they feel like asserting dominance. Some pods use mud rings to trap fish, coordinating movements like aquatic crime crews. They sleep half their brain at a time so they don't drown. And sometimes they commit acts of violence on porpoises for reasons no scientist has fully explained. Because the ocean contains whole moral frameworks humans haven't translated. Whales operate on their own mythic level. Blue whales are so massive their hearts weigh more than cars, and their arteries are wide enough for a human to crawl through, assuming you enjoy being dissolved in blood while spelunking. They communicate across hundreds of miles with low-frequency moans that travel through the water like a haunting dial tone. Humpbacks sing entire compositions that change over years like living albums passed pod to pod. Sperm whales hunt giant squid in pitch-black depths, diving deeper than most submarines, staying under for over an hour, then resurfacing with scars that look like someone attacked them with barbed wire. Sea turtles have been minding their own business for over 100 million years. Leatherbacks dive thousands of feet deep to eat jellyfish, holding their breath for close to an hour with lungs designed to collapse safely under pressure. Females return to the same beach they hatched on to lay eggs, no matter how far they've migrated. Scientists still don't fully understand how they navigate ocean basins with the accuracy of GPS strapped to instinct. Seals and sea lions blur the line between adorable and terrifying. Leopard seals in Antarctica look like they were designed by someone who wanted a reptile, a cat, and a torpedo combined. They hunt penguins by grabbing them mid-swim and whipping them apart at the surface. Elephant seals dive for 2 hours at a time to hunt squid, come back up to breathe, then repeat for months. Walruses scrape clams from the seafloor with whiskers so sensitive they can detect movement through sand. Sea otters, everyone's favorite floating fluff, use tools, wrap themselves in kelp to sleep so they don't drift, and eat a quarter of their body weight daily just to keep from freezing. Their fur is so dense it traps air instead of relying on blubber, and when oil spills coat it, they die from hypothermia before they ever drown. Meanwhile, polar bears swim for days across open water when ice breaks apart, hunting seals while the Arctic melts beneath them like a bad omen with teeth. Even fish people think they understand are operating on another schedule. Tuna can swim over 40 miles per hour and travel across entire oceans with migrations more precise than airline routes. Sunfish look like unfinished pancakes, but can weigh over 2 tons and dive hundreds of meters deep to escape predators. Some species of wrasser sleep in slime cocoons, others change sex based on population dynamics, and some bury themselves in sand so convincingly you'd never know millions of them are tipsy in the seabed waiting for shrimp to walk by. Penguins, though technically birds, have surrendered flight to become torpedoes with tuxedos. Emperor penguins dive deeper than 300 meters and hold their breath for over 20 minutes, surviving pressure that would knock a human unconscious. They raise chicks in Antarctic winters that could freeze engine oil, huddling in rotating circles to share warmth like feathered survival committees. Manatees drift through coastal waters like ancient grey potatoes, eating seagrass with the patience of monks. Dugongs, their slightly sleeker relatives, glide through Indo-Pacific lagoons, leaving feeding trails in meadows of underwater plants that regenerate faster thanks to their grazing. Both get hit by boats because humans forgot that engines plus soft mammals equals tragedy. Seabirds owe their survival to the sea's rhythm. Albatrosses soar for days without flapping, riding wind over waves and resting on the water when necessary. Puffins dive like aquatic darts and carry multiple fish in their beaks with a sideways grip that would make a pelican jealous. Pelicans themselves dive-bomb prey with neck pouches that expand like living nets. Frigate birds can fly for over a week without landing, stealing food mid-air and refusing to get wet because their feathers aren't waterproof. And we haven't even gotten to the reef clicks, the open water drifters, the sand dwellers, or the weirdos that live under ice shelves. Everything people think of when they picture the ocean is just the trailer. The full movie is darker, louder, older, and less invested in your comfort. The deeper you go into the catalogue of ocean creatures, the more it feels like evolution stopped asking permission and started submitting fever dreams as final drafts. The stuff living far from sunlight doesn't just bend expectations, it snaps them in half and throws them overboard. Even some of the mid-water species people barely hear about would look fictional if they showed up in front of a camera for more than 3 seconds. The barrel-eye fish is one of those biological plot twists. Its head is literally transparent, an actual see-through dome filled with fluid, with eyes pointing upward inside its own skull to stare through its forehead. Those eyes can rotate forward to eat prey, like periscopes made of cartilage and confusion. For decades, scientists thought its eyes were weird green nostrils because the face we assume is the face isn't even its real face. Everything about it looks like a design paperclip in a video game modded by someone who hates symmetry. Then there's the sarcastic fringehead, a fish whose name should have been a warning. It looks harmless until it opens its mouth, which unhinges and flares out into a massive psychedelic nightmare fan intended to intimidate rivals. When two males fight, they don't bite. They press their giant gaping maws against each other like they're trying to end arguments by measuring existential despair. The goblin shark swims around like an unfinished fossil that someone accidentally reanimated. Its skin looks like wet latex left in the sun, and its jaw isn't content to stay attached to its face. It shoots forward like a spring-loaded bear trap whenever prey appears, dragging its entire mouth out and snapping it shut before retracting it like nothing happened. Scientists call it slingshot feeding, but it's really ambush puppetry with teeth. If you keep diving into the dark, you'll eventually meet creatures like the tripod fish, which props itself on 3 elongated fins like a sentient camera stand and just waits for food to bump into its face. Or the faceless cusk eel, which lives so deep it lost its eyes entirely and wears a skin flap where a face should be, like someone put a pillowcase over evolution's head mid-design. Then there's the headless chicken monster, a type of swimming sea cucumber that uses fins to drift above the seafloor like a pink, gelatinous UFO with dangling frills. It looks like something a wizard summoned and then immediately regretted. Some sea cucumbers eject glowing organs when scared, and others liquefy their bodies to flow into crevices like haunted slime. The gulper eel, also known as the pelican eel, has a mouth larger than its entire body length. Its jaw can inflate into a pouch like a wet balloon, ready to swallow anything unfortunate enough to cross its path. Its tail ends in a bioluminescent lure that darts and flickers like a fishing line manned by insanity. If fish aren't enough, the invertebrates go even harder. Comb jellies don't sting, but their bodies refract light into rainbow pulses as they swim, like ghostly neon organs drifting through the void. Some grow lobes or tentacles that glow and curl as they net microscopic prey in slow motion. Others cannibalize relatives while sparkling like underwater chandeliers sponsored by doom. Siphonophores, cousins of the Portuguese man-o'-war, can grow longer than blue whales, some exceeding 100 feet in length. But they're not single organisms. They're colonies of specialized clones linked together like a living horror train. Each section has one job: stinging, eating, digesting, floating, or reproducing. And together they drift as one coordinated death ribbon. Some trail curtains of tentacles that leave chemical trails in the dark, leading prey straight into their paralyzing embrace. Vampire squid, despite the name, don't suck blood. They drift in low oxygen zones, where most animals can't breathe, and cloak themselves in webbed arms when threatened, turning into a floating sock puppet of horror. They feed on marine snow, catching detritus with mucus filaments and rolling it into balls like the abyssal version of meal prepping. Even worms get theatrical. The bone-eating zombie worm, Osidax, has no mouth or stomach. Instead, it secretes acid to bore into whale carcasses, then uses symbiotic bacteria to digest the fats and proteins inside the bones. They grow root-like structures into their food like demonic houseplants and release plumes of eggs into the water with no shame. And none of this accounts for the millions of species no one has recorded yet. Every few years, expeditions stumble across things with too many limbs, transparent skulls, or swim bladders that look like light-up organs. Footage surfaces of something drifting, glowing, or thrashing in slow motion before the camera malfunctions or the creature vanishes into the dark like it was never there. The ocean doesn't care if any of it makes sense. It isn't trying to impress or frighten or inspire. Those are just side effects humans feel when they notice pieces of it. Most of the planet's biomass lives underwater in forms humanity can't name, study, or even imagine yet. The abyss is less an ecosystem and more a constantly shifting archive of biology refusing to obey. The ocean doesn't just host the bizarre, it invents new methods of existence in places no life should logically function. Nowhere is that clearer than in the ecosystems built around hydrothermal vents, cold seeps, under-ice caverns, brine pools, and methane volcanoes that exist like alien worlds stitched into the planet. These communities form in darkness so complete that light isn't even a rumor, in water so pressurized that physics feels optional, and on chemicals so harsh that surface life would dissolve on contact. But down here, things thrive with the confidence of species that never asked for sunlight in the first place. Hydrothermal vents weren't discovered until 1977 because humans assumed nothing lived on the seafloor except sad fish and mud. Then Alvin, a deep-sea submersible, dropped into the Galapagos Rift and found what looked like underwater chimneys belching superheated water black with minerals. Those vents pump out fluid, hotter than boiling, but don't flash to steam, because the pressure keeps it liquid. The water carries hydrogen sulfide and metals like copper, iron and zinc, chemicals that should kill life, not feed it. But bacteria in these vents use chemosynthesis instead of photosynthesis, turning toxic compounds into energy the way plants turn sunlight into sugar. Those bacteria are the base of the food chain, coating rocks and living inside the tissues of worms, clams, mussels and crabs built to house them. Riftia pachyptela, the giant tube worm, looks like a red-plumed alien pipe organ rising over 6 feet tall. It has no mouth, no stomach, and no digestive system at all. Just a sack of symbiotic bacteria inside its body that converts chemicals into nutrients. The worm pumps in sulfurous water and oxygen, then lets its bacteria do all the work. They live in colonies so dense and productive that they support entire vent forests. Around them, skittering crabs, squat lobsters, shrimp without eyes, and snails with iron scales wander between mineral towers like they're walking through metal jungles. Cold seeps don't spew heat, but they leak methane, hydrogen sulfide, and hydrocarbons out of the seafloor, forming oases where chemosynthetic bacteria again run the show. Tube worms at cold seeps can live for over 200 years. Mussels cluster around cracks in the ocean floor, their shells blackened by chemical contact, while methane bubbles up through mats of microbes glowing like wet felt. Brine pools form in some of these zones, lakes under the ocean, so salty they form distinct surfaces you can fall into and die instantly. Cameras have filmed fish swimming above them, dipping in and immediately going belly up like someone dunked them in acid. Antarctic waters hide subglacial rivers and ice caves filled with transparent fish, blind amphipods and sea spiders the size of dinner plates. Under the Arctic ice, phytoplankton bloom in pockets of trapped light, feeding zooplankton that feed cod, seals and whales in ecosystems silent except for crackling ice and distant sonar calls. Greenland sharks cruise these frozen waters, some estimated to be over 400 years old, moving at speed so slow they look like time-lapse footage, dragging itself across the screen. Methane hydrates, ice lattices locking gas into solid form, pave the seafloor in some regions. When disturbed by earthquakes, warming water, or landslides, they can destabilize and release gas eruptions strong enough to choke entire water columns or fuel sudden explosions of microbial life. Some scientists suspect ancient methane bursts from the sea triggered mass extinction events by warming the atmosphere or suffocating oxygen supplies. Even within the cracks of rocks on the seafloor, microbial life thrives in water superheated by magma below the crust. These microbes metabolize everything from iron and arsenic to hydrogen and sulfur. They live in temperatures that would incinerate most DNA and pressures that would crush vertebrates into paste. They don't care if anyone sees them, because their existence doesn't require an audience, just minerals and time. When ships sink into these environments, they become reefs and fuel sources. Wood-boring clams drill into wrecked timber, digesting cellulose with bacteria, while microbes colonize metal hulls and paint surfaces. Whale falls trigger ecological chain reactions. Hagfish swarm in first, followed by sleeper sharks and amphipods, then worms and snails that burrow into bones and feed off lipids for decades. Skeletons become entire neighborhoods, and by the time they're gone, the sediment beneath has been transformed chemically and biologically. Even icebergs bring their own ecosystems as they drift and melt. They scrape up sediment from the seafloor when they ground, then release iron-rich meltwater as they break apart in warmer regions, fertilizing plankton blooms that feed krill, which feed whales. The death of an iceberg becomes the birth of a feeding event that echoes up the food chain until it reaches animals the size of buses. These extreme environments don't operate like the neatly labeled diagrams kids see in textbooks. They aren't rare anomalies. They're everywhere, scattered across the planet like subterranean test labs for biology. And for every vent, pool, cave, or seep humans have discovered, dozens more remain hidden, functioning in silence beneath miles of water that crushes cameras and erases footprints. Everything thriving in the deep seems engineered to break assumptions. Where there's no light, no oxygen, and temperatures swinging between freezing and volcanic, life still treats the darkness like rent-controlled housing. Even frozen methane-spewing fissures and under-ice labyrinths become crowded neighborhoods. It's as if the ocean took every condition that should kill living things and turned it into a startup opportunity. Take brine pools, literal underwater lakes filled with hypersaline water denser than the surrounding sea. They sit in depressions like alien ponds, their surfaces shimmering from refractive differences. Dip a remotely operated vehicle into one and it sinks like a stone. Anything that accidentally swims in dies instantly. Fish, crustaceans, even bacteria without proper adaptations. Yet around the edges, mussels, tube worms and crabs gather like partygoers, hugging the rails of a toxic hot tub, living off microbes that process methane and sulfur leaking from beneath. Then there are asphalt volcanoes, pits on the seafloor where heavy hydrocarbons ooze out like slow-motion tar fountains. Around them grow tube worms and crabs unaffected by a substance that would suffocate most organisms. Chemosynthetic bacteria bloom on the hardened ridges like oily moss, while fish lurk in shadows waiting for anything dazed enough to drift near. Ice worms live in glacial melt channels beneath frozen shelves, feeding on algae trapped in ice grains. Their bodies wiggle through slush at temperatures that should stop cellular function. Meanwhile, under the Arctic's permanent ice, strange comb jellies, amphipods and cod navigate a world lit only by the glow of microorganisms flickering like cold stars. The ice above them creaks, sighs and fractures, but life crawls and swims under it like the ceiling is just decoration. Vent shrimp near the mid-Atlantic ridge don't bother with eyes. They have photoreceptors on their backs that detect the faint glow of volcanic chimneys. When scientists first spotted them clustered by the thousands on pitch-black vents, no one knew how they weren't burning alive. Turns out they regulate their temperature and graze on bacteria farms growing right on the vent walls. Their larvae drift in darkness until currents deliver them to hot seeps that look like death but smell like home. Even the microbes down there flex harder than most animals. Some archaea metabolize arsenic, methane, or hydrogen produced by reactions between seawater and basalt. Others withstand temperatures above 120 degrees Celsius, well past the boiling point at the surface. Certain microbes trap uranium, convert sulfur to energy, or process radioactive elements like its compost. Some live inside rock pores so tiny they could fit millions in a pinhead, forming biofilms that hold entire ecosystems together, one invisible layer at a time. Deep-sea corals don't need sunlight or shallow reefs. They anchor themselves to submerged mountains, feeding on drifting plankton and detritus. Some colonies are estimated to be over 4,000 years old, predating written language. They build slow, spiraling structures that rising temperatures and trawling nets can destroy in seconds. Their skeletons hold chemical signatures that record ocean conditions through time like tree rings carved in calcium. Glass sponges build reefs of silica in Antarctic waters, filtering thousands of gallons of water a day and catching bacteria in a velvety matrix. Some species can halt biological processes when conditions worsen, then reanimate when things stabilize. Others light up when disturbed. Bioluminescence used not for hunting or mating, but to disorient anything dumb enough to bump into them. The Mariana snailfish, filmed over 26,000 feet deep, looks almost delicate, with translucent skin and wing-like fins. But its cells contain compounds that prevent proteins from collapsing under pressure strong enough to crush submarines. They feed on amphipods that graze on organic snow drifting down from above, turning death from the surface into life in the trench. Even more absurd is the yeti crab, which looks like a crustacean dressed in shag carpet. It lives by hydrothermal vents, waving its hairy claws over plumes of mineral-rich water. Bacteria grow in the hairs, and the crab scrapes and eats them like a gardener nibbling its crops. It's part chef, part farmer, part survivor of conditions that should erase anything soft-bodied. And for every bizarre, deep dweller recorded, there are entire families of yet unseen organisms hiding in crevices, trenches, and caves. Some only reveal themselves when vents shift, quakes crack open new fissures, or explorers accidentally crash into them with remotely operated vehicles. The deep doesn't advertise. It waits. Life under pressure doesn't follow rules. It writes new ones in the dark, cushioned by crushing tons of water and silence older than continents. Sunlight might make things pretty, but the deep proves existence doesn't need beauty, comfort, or witnesses to thrive. Even with all the wildlife tearing up the darkness, one of the ocean's greatest tricks isn't teeth or bioluminescence. It's how much life survives by being barely alive at all. The deep doesn't reward energy waste. Down there, survival is an art of stillness, hiding, silence, and weird biology that bends the rules of metabolism like it's a suggestion rather than a law. You don't need speed or sunlight when your main competitors are scavengers, microbes, or nightmares with slow-motion reflexes. Take the Greenland shark, the undead grandparent of the sea. It moves at a speed that would embarrass a sloth, drifting through the Arctic deep like a funeral procession. Yet it can reach lengths of over 20 feet. Its flesh is toxic if eaten raw because of high urea and trimethylamine oxide content, meaning it tastes and functions like fermented ammonia unless processed properly. Scientists estimate some individuals are between 300 and 500 years old, making them older than the United States, the printing press, and maybe even a few unsolved family curses. They eat sleeping seals, fish, and whatever rotten carcass they drift across, including entire reindeer and polar bears when luck or gravity intervenes. Then you've got the vampire squid. Not a squid, not a vampire. More like a goth umbrella floating through perpetual night. Its name, Vampiroteuthis infernalis, literally means vampire squid from hell. But it doesn't hunt like a demon. It survives in oxygen minimum zones where most life gives up, using nearly no energy and feeding off drifting organic debris. When threatened, it wraps itself with its webbed arms and turns inside out like a cloak of spines and mucus. If things get worse, it ejects a glowing cloud of bioluminescent slime and glides away like an offended ghost. Hagfish deserve their own horror genre. They have skulls but no jaws, eyes that barely function, and faces only an abyss could love. When they find a dead or dying creature, they burrow into it and eat from the inside out. If a predator tries to bite one, the hagfish releases slime so thick it can clog gills and choke the attacker in seconds. A single hagfish can fill a bucket with mucus in under a minute if agitated. They've been using this defense for over 300 million years, which means evolution looked at them and said, good enough. Sea pigs, yes, that's a real name, are pudgy pink sea cucumbers walking along the seafloor on tube legs like demented stress toys. They feed on marine snow, the constant drizzle of organic particles and microscopic corpses that sinks from above. Marine snow is the ocean's recycling program, a never-ending rain of death, feeding everything too slow or too far down to chase live prey. For every giant squid battle or shark hunt, there are millions of quiet feeders sifting through the leftovers like it's a buffet of decay. Tripod fish stand on elongated fins in the pitch dark, facing into the current with mouths open, waiting for food to drift in. They don't swim unless necessary. Their eyes are useless because there's nothing to see, so they rely on pressure and vibration. They literally perch in oblivion like underwater scarecrows. Some jellyfish take stillness to cosmic levels. The immortal jellyfish, Turritopsis dohrnii, can revert its adult cells back to a polyp state after reaching maturity, basically Benjamin buttoning itself to avoid death. There's no confirmed limit to how many times it can do this, meaning some individuals could be older than recorded human civilization. It doesn't brag. It just quietly refuses the concept of expiration. Even fish that do move operate like ghosts. The rat tail, or grenadier, is one of the most common deep-sea fish on the planet, yet most people have never heard of it. They drift through trenches, eating crustaceans and carrion with giant heads and tapering tails that end in wisps. Their bodies look stretched by a curse, and their eyes reflect light like haunted glass. Other creatures don't just slow down, they freeze time. Some deep-sea bacteria can enter dormant states for thousands of years, buried in sediment beneath the seafloor, only to wake when conditions change. Samples have been cultivated from layers tens of millions of years old, revived like biological time capsules. They aren't dramatic, they're patient. Even whales contribute to this economy of stillness. When they die and sink, their bodies become whalefuls, brief explosions of life that last decades. First come the scavengers, then bone-eating worms and bacteria, then entire food webs that turn the corpse into apartments and restaurants. The deep wastes nothing because nothing down there can afford to. Creatures adapt not by conquering but by enduring, slowing their hearts, lowering metabolisms, storing oxygen in blood and muscle, and waiting out food scarcity with the calm of entities that don't track time. They don't measure survival in days or years. They just continue. For all the patience and minimalism reigning in the deep, there's a flip side. Organisms that push biological limits so hard they might as well be glitches in reality. They don't just endure darkness, pressure, and starvation. They weaponize the abyss in ways that don't make sense until you accept that the ocean stopped asking for permission a long time ago. Start with comb jellies, which don't sting like regular jellyfish, but use sticky cells to snag prey. They move using rows of cilia that refract light into spectral waves, turning their bodies into drifting prisms. Some are nearly invisible until they catch light and explode into rainbow pulses like ghost circuitry traveling through water. Others grow lobes, tentacles, or inflatable sacs to trap plankton and larvae in drifting nets of living glass. Then there are siphonophores, which are technically colonies of cloned individuals fused into one organism. Some stretch over 100 feet long, with each segment specialized. Some sting, some digest, some steer, some reproduce. They move like elegant death banners, and when lights from submersibles hit them, their bodies ripple with alien luminescence that looks more like programming than biology. If fish, shrimp, or anything with bad luck brushes against the wrong tendril, it's paralyzed and dragged into digestive chambers it never saw coming. The anglerfish is iconic for a reason. Females carry bioluminescent lures on rods protruding from their heads, waving fleshy lights to trick prey into swimming closer. But the real horror is their mating strategy. Males are tiny compared to females, some the size of a finger, and when they find a mate, they bite onto her and fuse into her body, losing their eyes, organs, and independence. Eventually, they exist only as sperm-producing attachments grafted into the female's bloodstream. By the end, she's wearing her lovers like biological earrings. The stoplight loose-jaw fish has a hinged jaw that detaches from its skull to snatch prey. It emits red bioluminescence, which most deep-sea creatures can't see, giving it invisible headlights to spot victims in total darkness. It hunts with night vision in a world where night is permanent. Hatchetfish carry upward-facing tubular eyes that detect silhouettes of prey against the faint light filtering from above. Their bodies are mirror-coated with reflective scales that mimic the dim background around them, erasing their outlines like built-in invisibility cloaks. Some adjust the brightness of their camouflage by producing their own bioluminescence to match light levels from above. Dragonfish go even further. They produce both blue and red light, and their teeth are clear so they don't reflect their own glow and give away their position. They can extend their jaws outward like biological spears to snatch prey and swallow it whole before retracting their skulls into shape. Their larvae drift near the surface with protofangs and feelers longer than their bodies before descending into adulthood like nightmares dropping through a trapdoor. Even octopuses in the deep abandoned the rules. The Dumbo octopus uses ear-like fins to fly through water, its webbed tentacles fluttering like a cloak. It doesn't ink, because who are you confusing in a place where inking only blinds you? Others, like the blanket octopus, unfurl massive webbed membranes when threatened, looking like a glowing ghost parachute. Females can be over 6 feet long, while males are barely an inch. One of the most extreme size differences of any animal on Earth. And then there are the creatures scientists barely have names for. Filamentous things that drift like hair in a dream, translucent discs undulating like plastic bags possessed by thought, worms with jaws like broken scissors, shrimp with glowing organs inside their heads, and microbes thriving on rock, gas, and metal rather than sunlight or sugar. The deep is less a habitat and more a testing ground for everything that shouldn't work but does. Life isn't rare, it's relentless. And each new expedition drops cameras into darkness expecting emptiness, only to find another creature rewriting the limits of what counts as alive. For all the monsters drifting in the depths, the ocean doesn't just house creatures, it engineers illusions. Bioluminescence is the language of darkness, a communication system, lure, distraction, weapon, and disguise rolled into chemical light. Down where sunlight dies, brightness becomes strategy, and millions of species wield glow like magic no one asked permission to use. Dinoflagellates, microscopic plankton, light up when disturbed, coating waves with electric blue glitter. At night, shorelines glow like galaxies breaking on sand, and every footstep, oarstroke, or fish dart flickers with neon fire. Some bays glow so intensely, boats leave trails like molten metal, and swimmers look possessed by stars. This light show isn't decorative, it's defense. The glow startles predators or alerts bigger predators to attack the one doing the chasing. It's like a burglar alarm made of glitter and panic. Jellyfish take it further. The Atolla jellyfish has a bioluminescent burglar alarm response. When attacked, it flashes rapidly in bright rings to attract something larger that might eat its predator. Other jellies use slow pulses to mimic sinking lights, drawing prey upward into invisible tentacles. Some glow from within. Others produce flashing patterns across their bells, like living lanterns spinning through the void. The anglerfish's lure isn't just a flashlight. It's full of bioluminescent bacteria that live symbiotically in a fleshy sac. Victims swim up thinking they found food, not realizing they're looking into the mouth of something that swallowed the dark and grew teeth in it. Hatchetfish use bioluminescence in reverse, producing light on their bellies to erase their shadows when seen from below, a trick called counter-illumination. Shrimp have chemical flash bombs. Some puke glowing clouds when attacked to blind predators and vanish in the confusion. Even sharks use glow. The lantern shark has photophores along its body, turning its belly into a cloak of light to blend with the surface glow above. Some species have glowing spines, jaws or tails, flashing signals to mates or warning off threats. In the deep, it's not always about being seen. Sometimes it's about being less seen than whatever wants to eat you. Siphonophores dazzle entire water columns. Some flash in waves down their bodies, rippling like electric ribbons. Others release glowing threads that drift away, tricking predators into chasing decoys made of light. Firefly squid gather in such numbers during spawning that coastlines in Japan light up like underwater auroras, their bodies glowing blue beneath waves as fishermen scoop them in by the thousands. The stoplight loosejaw fish carries red bioluminescent organs, rare because most deep-sea creatures can't see red. It hunts with invisible light like a sniper using infrared. Its jaws unhinge and strike prey before they even register movement. Meanwhile, dragonfish are born with glowing patches on their cheeks that ignite when they open their mouths, signaling to mates or terrifying prey. Glowing plankton aren't just showpieces. They're the ocean's most abundant light source. A single liter of seawater can contain thousands of bioluminescent organisms ready to burst into light when agitated. Even currents can trigger mass glowing events, turning underwater turbulence into silent lightning storms. Squid flex their glow organs like horror artists. The Hawaiian bobtail squid harvests bioluminescent bacteria in a special chamber, feeding and housing them. In return, the bacteria glow to mask the squid's shadow from predators below. If the bacteria misbehave, the squid ejects and replaces them like a landlord with standards. Other squid shoot glowing mucus instead of ink, confusing predators in clouds of light instead of darkness. Some brittle stars, close relatives of starfish, snap their arms and glow at the breaks to distract predators while they escape. Ostracods, tiny crustaceans, use glowing chemicals during mating displays, shooting sparks that drift like underwater fireflies. Even marine worms launch spiraling fireworks during spawning events, glowing green or blue as they rise in coordinated bursts, releasing eggs and sperm in the light before being eaten, ignored, or both. Bioluminescence isn't rare, it's normal. Over 3/4 of deep-sea organisms use it in some form. For many, it's the only language. They flash to mate, to hunt, to flee, to lie, to hide, to summon, to misdirect. In the absence of sun, light is currency, camouflage, and threat. The surface world burns fuel to imitate what the deep has been doing for hundreds of millions of years, without noise, waste, or spectacle for its own sake. For every creature using light as a tool, there are others using it as a trap, a signal, a dinner bell, or a fake identity. In the deep, bioluminescence isn't decoration. It's the difference between eating, hiding, mating, or getting swallowed by something older and meaner. Down there, light isn't rare. What's rare is not glowing. Deep-sea anglerfish may get all the attention with their dangling headlamps, but their relatives are equally theatrical. Some species use multiple lures, one for prey, one for mating, one just to freak out anything watching. Others pulse their lights in irregular patterns to mimic injured fish. In the abyss, looking weak is bait. The cookie-cutter shark glows, except for its throat, which is darker. That missing patch makes its silhouette resemble a smaller fish from below. Larger predators swim up, thinking they found a snack. Then the shark latches on and twists out a chunk of flesh like it's coring fruit. Whales, tuna, dolphins, and submarines have all been gouged by something barely 2 feet long wearing a glow suit. Loose-jaw dragonfish combine invisibility and terror. They produce far-red light through photophores under their eyes, an illumination most prey can't detect. It's biological night vision goggles paired with a face only pressure could love. When they strike, their jaws swing open almost 180 degrees and clamp around prey using clear fangs as long as their skulls. Sharks aren't the only ones in stealth mode. Bioluminescent camouflage, counter-illumination, has evolved in everything from squid and krill to shrimp and fish. Firefly squid flash patterns across their bellies to match moonlight. Some deep-sea hatchetfish adjust their photophores in real time to balance brightness and shadow like underwater cloaking devices. Certain squid, like Taningia danae, don't bother with subtlety. They use massive bioluminescent organs on their arms to flash explosive bursts of light while attacking prey, stunning them with both impact and shock. Others light up tentacle tips like flickering candles, luring smaller animals to their doom. Even plankton coordinate light with murderous efficiency. When predators swim through blooms of dinoflagellates, water around them erupts in sudden flashes. That glow isn't just fright. It's a call to bigger predators. Fresh meat here, hurry! It's weaponized alarm systems disguised as fairy dust. Jellyfish like Halitrephes marci burst with internal fireworks when touched, bands of light racing across their bells like neon veins. Others, like the crystal jelly, produce light only when disturbed, converting chemical energy through proteins that revolutionized medical imaging. The ocean has been lighting itself for eons, while humans scramble to figure out glow sticks. Some worms leave trails of light as they move, flickers marking territory or attracting mates. Swima bombiviridis, the bombardier worm, detaches glowing sacs from its body when attacked, leaving bright decoys drifting in darkness like underwater flares. The predator follows the lights while the worm escapes through shadows. Even predators fall for it. Female scale worms mimic the bioluminescent signals of males from other species, luring them close to kill them. It's catfishing with literal light. Certain squid have organs that glow in shifting colors to confuse prey, blending patterns of Morse code and hallucination. Some animals don't use their own glow. They hijack others. Bobtail squid cultivate colonies of bioluminescent bacteria that live in special organs. The squid controls the intensity of the glow to match ambient light, erasing shadows. At dawn, it expels most of the bacteria and regrows the colony daily, like a living lantern rental. Beneath the Arctic ice, comb jellies and amphipods flash in waves across cracks like silent lightning. In the mid-water twilight zone, ctenophores drift, trailing shining tentacles that catch copepods like glittering snares. Shrimp and krill fire glowing vomit or fecal streams at enemies to create light trails predators follow while they vanish. Even death glows. Bioluminescent bacteria colonize corpses in the shallows, making dead fish and decaying wood emit eerie light. Sailors once reported phantom ships and glowing bodies drifting at night, never realizing they were looking at decomposition lit by microorganisms turning rot into signal flare. And the scale is absurd. Scientists estimate that over 75% of deep-sea organisms glow in some way, and some regions see more light bursts per minute than lightning above the clouds. Where humans imagine darkness, the ocean is blinking, pulsing, shimmering, and signaling in a silent network of light languages older than speech. For all the shimmer and silence below, the ocean is never quiet. Sound is its language, its surveillance system, and its rumor mill. While light dies within a few hundred feet of the surface, sound races through water almost 5 times faster than in air, traveling for hundreds or thousands of miles without losing strength. Down there, hearing replaces seeing, and the creatures that master noise either eat better, live longer, or avoid becoming leftovers. Whales are the undisputed heavyweights of underwater acoustics. Blue whales produce calls that can reach 188 decibels, louder than jet engines, and those low-frequency moans can travel across entire ocean basins. They speak in rhythms scientists still can't decode. Pulses, growls, booms, and songs longer than some movies. Each population carries its own dialect, and over time, songs evolve like folklore passed down through generations. Humpback whales sing structured compositions with verses and refrains that change annually. Some of those songs take 30 minutes to complete and are performed on loop for hours, sometimes days. Sperm whales use clicks powerful enough to stun prey. Their vocalizations can exceed 230 decibels, and up close, the sound could kill a human by collapsing organs. They use sequences called codas to communicate with family units, passing culture across matrilineal clans. Dolphins take things further with names. Each individual creates a unique signature whistle, and others use those whistles to call them specifically. In crowded pods, they coordinate hunts with whistles, clicks, and body slaps on the water. But sound in the ocean isn't just communication, it's navigation, hunting, deception, and evasion. Orcas hunt using strategy and noise like coordinated military units. Some pods use tail slaps to corral fish into bait balls. Others imitate the calls of prey to lure them in. Certain orca ecotypes have decided seals taste best, while others eat only fish, and their hunting sounds differ like regional accents. Beluga whales, nicknamed sea canaries, produce chirps, trills, whistles, and squeaks so varied they sound like an orchestra trapped in an ice cavern. Shrimp, some of the smallest players, make some of the biggest collective noise. Snapping shrimp, also called pistol shrimp, close specialized claws so fast they create cavitation bubbles that burst with a crack louder than gunfire. Those snaps create shock waves strong enough to kill small fish or stun prey. Entire reefs filled with snapping shrimp sound like frying bacon or static when recorded. A constant crackling chorus loud enough to confuse sonar. Fish make noise too. Some grind their teeth, some vibrate their swim bladders, others drum their fins against their skeletons. The toadfish grunts like a disgruntled generator during mating season. Drumfish make booming sounds at dusk that can echo through estuaries. Even herrings pass gas from their swim bladders to communicate, producing high-frequency bubbles scientists politely refer to as fast, repetitive ticks. Sound detection is equally advanced. Many deep-sea species use lateral lines, sensitive mechanoreceptors, to detect vibrations in complete darkness. Sharks hear infrasound, low-frequency pulses made by struggling or injured animals. Seals sense echoes off ice and currents. Some fish track movement by feeling pressure shifts long before anything comes into view. Humans only realized how noisy the ocean was once we built hydrophones for warfare. In the 1960s, while listening for submarines, the Navy accidentally recorded mysterious deep-sea booms, roars, and moans with unknown origin. Some were icebergs scraping the seafloor. Others were volcanic eruptions, landslides, gas releases, or whale choruses so vast they drowned out machines. Sounds like the bloop recorded in 1997 was so loud some thought it came from a creature bigger than any known animal. Eventually, it was traced to icequakes, massive ice shelves cracking and carving underwater. In the absence of sight, the sea is mapped by pressure waves. Dolphins use echolocation, firing clicks that bounce off fish, rocks, or divers. They can tell the difference between a human holding a metal object and one holding nothing, just by sound signatures. Sperm whales echolocate prey a mile deep in the dark, sending acoustic beams so intense they may stun giant squid before eating them. Even coral reefs have a soundtrack. Larval fish drifting in the open ocean use reef noise, crackles, grunts, snaps, to find their way home. When reefs die from bleaching or pollution, the silence drives larvae away, leaving the habitat emptier over time. Ships, drilling, sonar, and engines disrupt these soundscapes, drowning communication in mechanical thunder. The surface world thinks of silence as absence. The ocean knows silence doesn't exist. Everything hums, cracks, clicks, growls, booms, and whispers. To live underwater is to either listen or vanish. For the ocean, sound isn't just background. It's architecture, conversation, and occasionally an act of violence. While sea life built its world around acoustic reality, humans showed up blasting engines, drilling rigs, sonar, and explosions into the water like the planet handed them a megaphone and no supervision. The result is an underwater soundscape so cluttered that whales lose their migration paths, dolphins abandon territories, and fish fail to mate because they can't hear each other over propellers and seismic blasts. Shipping lanes create constant low-frequency rumble that blankets entire regions. Cargo ships, cruise liners, tankers, and fishing vessels together form what scientists call acoustic smog. The noise can travel hundreds of miles, overlapping with the frequencies whales and large fish use to navigate or detect threats. In the North Atlantic, humpback whales have responded by singing louder and shorter songs. A forced evolution of communication just to be heard over engines hauling televisions and soybeans across the sea. Navies contribute their own brand of chaos. Mid-frequency active sonar used in submarine detection sends out sound pulses so powerful they can rupture the ears and organs of marine mammals. Mass strandings of whales have been linked repeatedly to naval exercises, with animals washing ashore bleeding internally, disoriented or dead. Beaked whales are especially vulnerable. They panic dive to escape the sound and suffer decompression sickness from ascending too quickly afterward, their bodies never designed to panic in pressure. Seismic surveys used by oil companies produce blasts from air guns that detonate every few seconds to map the seafloor. These pulses can continue non-stop for months across tens of thousands of square miles. For humans, the equivalent would be living in a war zone soundtrack where explosions never stop long enough for a thought to form. Fish exposed to seismic noise show stress responses, internal injuries, and lower reproductive success, while some crustaceans lose legs and antennae from shock waves. Fishing vessels use sonar to detect schools of fish, layering even more artificial sound into ecosystems already buzzing with engines. Even recreational boats with small motors can disrupt communication among dolphins, seals, or manatees. For animals that rely on silence between calls or precise intervals between echoes, even small interruptions can mean missed prey or unseen predators. Then there are explosions. Underwater mining, military testing, and construction detonate charges that create acoustic shockwaves strong enough to kill everything in the vicinity instantly. Fish exposed to blasts can suffer ruptured swim bladders, shattered ear bones, or blindness. Even if they survive, they may lose the ability to orient themselves, feed, or avoid being eaten. Noise pollution also distorts migration. Grey whales detour hundreds of miles to avoid high-traffic zones, burning extra energy and risking starvation. Blue whales feeding off California have stopped using certain feeding grounds because of non-stop ship traffic. Dolphins near coasts change vocal patterns, calling less often and abandoning group synchronization when humans turn the water into a speaker system. But the ocean isn't just harmed by sound. It also produces its own forces. Icebergs scraping across the seafloor generate what are essentially underwater earthquakes, grinding, roaring collisions that can last minutes and be heard across continents. Seafloor landslides triggered by quakes or methane bursts rumble like collapsing mountains. Submarine volcanoes erupt with blasts that carry through the water column as rolling booms that no one hears on land. Even fish storms are a thing. Massive schools of fish swimming in synchronized movements produce low-frequency vibrations that reverberate across miles. Crustaceans crawling across reefs at night generate background crackle. Waves and wind create constant noise at the surface, and as storms intensify with climate change, atmospheric energy keeps getting punched into the water. Biological sound isn't always pleasant. Some species of grouper produce mating calls like generators with indecision. Weddell seals under Antarctic ice make noises that sound like alien transmissions or malfunctioning synthesizers. Black drumfish create droning booms that can shake house pilings and keep waterfront residents awake. Croakers and grunters vibrate their swim bladders loudly enough to drown out smaller species nearby. Sound is information, and when it's corrupted, ecosystems unravel. Larval fish that once located reefs by sound drift aimlessly when the natural acoustic signature is drowned out by engines. Predators miss prey. Prey miss danger. Mothers lose contact with calves. Migrations falter. Reproduction plummets. Few people think of noise as pollution because you can't bottle it or mop it up. But the ocean hears everything humans do to it. And unlike plastic or oil, sound doesn't linger. It slices through the present, disrupting instincts older than bones. Humans like to imagine the ocean as a backdrop, a place for sunsets, snorkeling, and vacation wallpaper. Meanwhile, it's been regulating the planet's climate since before mammals had kneecaps. Without the ocean absorbing, redistributing, and storing heat, Earth would swing between inferno and ice age with zero warning. Instead, water acts like the planet's thermostat, sponge, and conveyor belt all at once, quietly fixing messes it never agreed to manage. Over 90% of the excess heat trapped by greenhouse gases ends up in the ocean. If that heat stayed in the atmosphere, surface temperatures would have already cooked crops, collapsed food chains, and turned cities into convection ovens. The ocean takes the hit, pulling warmth deep below the surface through mixing, circulation, and current systems humans barely understand. But it doesn't erase the heat. It moves it, holds it, and waits for consequences to catch up. Currents like the Gulf Stream, Kuroshio, and Antarctic Circumpolar Current don't just move water, they carry climates on their backs. The Gulf Stream alone keeps Europe from freezing into a glorified tundra. Its warm waters travel from the tropics toward the North Atlantic, releasing heat into the air and allowing places like Ireland and Norway to avoid Siberian weather despite sharing similar latitudes. If that current slows down due to melting ice altering salinity, entire continents will relearn the meaning of winter. The thermohaline circulation, Earth's great ocean conveyor belt, moves water based on temperature and salt content. Warm, salty surface water cools and sinks in the North Atlantic, flowing deep toward Antarctica and eventually rising again in the Pacific or Indian Oceans. A single circuit can take 1,000 years, but it stabilizes the atmosphere, supports ecosystems, and prevents regional climates from spiraling out of balance. It's not a suggestion, it's the operating system of the planet. Winds drive surface currents too, pulling water sideways through something called the Coriolis effect. That's what creates gyres, immense rotating systems like the North Pacific Gyre, which also happens to collect floating garbage into continent-sized trash soups. These gyres move heat horizontally, while upwellings bring cold, nutrient-rich water to the surface, supporting fisheries that feed billions of humans who don't know plankton from plywood. Ocean heat doesn't just sit politely. It fuels storms. Hurricanes, cyclones, and typhoons are powered by warm water evaporating and spiraling upward. The hotter the ocean's surface, the more violent the storms. Category 5 monsters don't form over cold water. They form where heat piles up like tinder under a flame. As sea temperatures rise, storm seasons grow longer, stronger, and more unpredictable. The ocean also absorbs roughly a third of the carbon dioxide humans pump into the air. When carbon dioxide dissolves in water, it forms carbonic acid, which lowers pH and begins dissolving calcium carbonate structures. That acidity erodes coral reefs, weakens shells of plankton and mollusks, and disrupts food chains from the bottom up. Coral reefs, which support a quarter of marine biodiversity, bleach when water gets too warm and die when acidity drains their skeletons. Dead reefs don't regrow quickly. They crumble. Sea ice, especially in the Arctic, reflects sunlight back into space. As it melts, darker ocean water absorbs more heat, accelerating warming in a feedback loop scientists have been screaming about for decades. The Antarctic ice shelves hold back glaciers the size of countries. When warm water eats them from below, the glaciers slide faster into the sea, raising global sea levels inch by inch until coastlines redraw themselves like dissolving borders. And the ocean doesn't distribute the pain evenly. Some regions are heating faster than others, altering storm paths, killing kelp forests, shifting fish migrations, and turning formerly balanced ecosystems into deserts or chaos pools. Marine heat waves now strike without warning, wiping out species that evolved over millennia in temperature-stable waters. Australia's Great Barrier Reef has suffered back-to-back bleaching events so severe that vast sections may never recover, transforming from vibrant habitats to ghostly remains. Phytoplankton, the microscopic plants of the ocean, produce over half the oxygen humans breathe, but they need specific temperature, light, and nutrient conditions to thrive. When currents shift or waters warm too much, these plankton blooms collapse, affecting everything above them. The air we breathe and the storms that hit our shores depend on organisms too small to see and systems too complex to pause. All the while, humans treat the ocean like a dumping ground, a heat sink, a buffet, and a travel brochure. But the ocean isn't a side character. It's the main engine running the planet, and every imbalance, temperature, chemistry, ice melt, circulation, is a warning flare disguised as water. The ocean may be holding the planet together, but it's also reaching its breaking points in slow, vicious increments. The changes aren't loud at first. They creep in through temperature shifts, disappearing habitats, fish migrations gone sideways, and storms with tempers no one budgeted for. The sea doesn't crack overnight. It tilts reality 1 degree at a time until the consequences feel biblical. Sea levels are rising not just because ice melts, but because water expands as it warms. Thermal expansion alone has contributed significantly to the inches creeping up coastlines. Combine that with glaciers in Greenland and Antarctica dumping fresh water into the ocean faster than ice sheets can stabilize, and you get entire island nations planning evacuations. Kiribati, the Maldives, Tuvalu, and the Marshall Islands are already buying land elsewhere because their future maps don't include themselves. Saltwater intrusion poisons groundwater in coastal regions as rising seas push brine into freshwater aquifers. Farmlands rot from below, and trees die from salt creep before anyone notices what's happening. In places like Bangladesh, Florida, and Vietnam, fields that once produced rice or fruit now grow nothing but salt-resistant weeds and frustration. The ocean doesn't need to drown land to destroy it. It just has to soak it. Storm surges ride in on higher baseline sea levels, turning what used to be once-in-a-century floods into regular seasonal events. Hurricanes now push tides into cities built at elevations that seemed safe a generation ago. Roads, power grids, and homes get wiped out, and governments call it unprecedented, even though the warnings came decades earlier. Coastal erosion accelerates when rising seas, stronger storms, and dying coral reefs combine forces. Beaches vanish not because they're disappearing, but because waves eat away land faster than it can rebuild. Barrier islands migrate landward, taking houses, roads and resorts with them. Mangroves that anchored shorelines drown when roots can't keep up with water level rise, leaving coasts exposed like stripped bone. And currents, the arteries of the planet, are shifting. Melting ice dilutes surface salinity in the North Atlantic, slowing down parts of the Atlantic meridional overturning circulation. If that system stalls enough, Western Europe freezes while tropical regions overheat. Rain belts move, fisheries collapse, and monsoon systems twist into something unrecognizable. Scientists call it disruption. The ocean calls it physics. Marine heat waves kill off underwater ecosystems in weeks. Kelp forests collapse when temperatures rise a few degrees, leaving sea urchins to eat bare rock. Coral reefs bleach and die when symbiotic algae abandon them under stress. Without reefs, shorelines lose natural storm barriers and fish lose nurseries. Some reefs don't recover in centuries, if at all. Fish migrations shift poleward as waters warm. Cod abandon traditional fishing grounds. Sardines, anchovies and mackerel move into new waters, forcing entire fishing industries to chase them across borders. Predator-prey relationships get scrambled. Species that never met before now compete or kill each other with zero evolutionary preparation. Oxygen levels in the ocean are dropping. Warmer water holds less oxygen, and stratification prevents mixing that would replenish deeper layers. Dead zones expand in coastal areas fed by agricultural runoff and sewage. Fish flee where they can. Everything else suffocates quietly. Some areas, like parts of the Arabian Sea and Gulf of Mexico, grow seasonal oxygen minimum zones so large they alter migration and nutrient cycling across continents. Meanwhile, melting ice opens new shipping routes in the Arctic, and nations scramble for territory and resources under disappearing glaciers, like vultures circling a thawing planet. Polar bears starve on land because sea ice vanishes earlier each year, shrinking the hunting platform they depend on to catch seals. Walruses crowd shorelines and stampede each other to death because their offshore hauling grounds melted into open water. Even ancient rhythms tied to temperature are unraveling. Phytoplankton blooms hatch earlier or later than the species that eat them. Birds and fish arrive out of sync with spawning cycles. Migrations misfire. Every delay or shift triggers ripple effects sent through food webs that stretch from microbes to megafauna. And the ocean stores the receipts. Oxygen isotope ratios in coral skeletons reveal heat spikes. Sediment cores show past extinctions linked to temperature rise. The deep sea traps carbon and memory in layers of silt and carcasses, while the surface acts like it has amnesia. For now, the ocean still swallows heat, hides the worst effects, and buys the land time it doesn't deserve. But buffers break. Patience ends. And when water decides it's done being polite, nothing on land negotiates with the tide. For all the science and wonder, the ocean has always been a magnet for myths, fears, and hallucinations dressed as folklore. Long before sonar, satellites, and submersibles, humans stood on the shore, stared at the horizon, and assumed the water was storing gods, monsters, and the consequences of curiosity. Most cultures didn't see the sea as scenery. They saw it as a temperamental entity that swallowed ships, spawned legends, and occasionally spit back evidence that people had no business being near it. Mermaids didn't start as Disney mascots. In ancient Assyria, Atargatis was a goddess who turned herself into a fish out of shame. But artists couldn't figure out how to draw a woman with a full fish body, so they split the difference and made her half-human. Greek sirens were birdwomen at first, then evolved into ocean dwellers who lured sailors with songs, which honestly feels like a career upgrade. Sailors later swore they saw mermaids across the Indian and Atlantic Oceans, most likely manatees seen through exhaustion, rum, and loneliness. Still, the myth spread, painting the sea as a place where desire and danger shared the same silhouette. sea serpents haunted every map before people learned to shut up and measure. Norse legends spoke of Jörmungandr, a serpent so vast it encircled the world and held its tail between its teeth. Medieval sailors reported creatures longer than ships with humps rolling above the surface like moving hills. The kraken emerged from Scandinavian lore as a cephalopod the size of islands, dragging vessels into whirlpools and devouring crews whole. It was based on real giant squid, but time and terror inflated the tentacles to fantasy proportions. Even after exploration became less guesswork and more survival, tales of creatures persisted. In 1848, the HMS Daedalus reported a 60-foot serpent off the coast of Africa. Newspapers printed sketches of long-necked beasts rising from waves. Scientists shrugged until they found oarfish, ribbon-like fish that can reach 50 feet long and surface when injured or dying, startling fishermen into dropping nets and faith alike. Oarfish sightings are still blamed for tsunami omens in Japan, where they're called messengers from the sea god's palace. Then there's the shadow category, things too fast, large or strange for witnesses to classify. Fishermen report bioluminescent silhouettes the size of buses moving beneath boats with no dorsal fins. Deep-sea cables have been found wrapped in sucker scars no submarine could mimic. Sonar has captured shapes the length of airplane wings, rising, stalling and sinking again before anyone gets a visual. But the myths don't stop at animals. Whole cities supposedly rest underwater. Atlantis gets all the publicity thanks to Plato, who described it as a powerful kingdom swallowed by the sea in a single day and night. Historians argue it was an allegory. Others point to Thera, Doggerland, Helik, Yonaguni, or submerged ruins off India as real-world ghost towns devoured by rising water. Whether Atlantis existed doesn't matter. The ocean has erased enough coastlines to make the idea feel less like fantasy and more like a recurring event. Sailors brought back stories of ghost ships, glowing seas, vanishing islands, and calm water that devoured fleets without warning. They described walls of water rising from flat horizons, storms appearing out of cloudless skies, and lights flickering under the surface like cities built upside down. Some saw waterspouts that stretched from sea to cloud like liquid tornadoes. Others witnessed rogue waves big enough to swallow vessels whole. Except back then, no one believed them because landlocked skepticism always outvotes saltwater trauma. Legends of beings beneath the water persist across cultures. Selkies in Scotland that shed seal skins to become human. Naga in Hindu and Buddhist tradition. Serpentine deities ruling river and sea realms, the Caribbean's Mamadlo guarding reefs and punishing intruders, the Philippines' Sirena and Berberoka lurking in rivers and coasts, pulling people under with sweet deception. Myths weren't just horror stories. They were boundary markers in a world without charts. Even today, people report things the camera can't explain. Lights flickering miles offshore with no boats around. Silhouettes gliding under ice, sounds recorded deep below the range of whales. Humans keep waiting for permission to believe fear again, even though they never should have stopped. As much as myths tried to make sense of the sea, there are real disappearances, vanishings and phenomena that feel like folklore wearing data. The ocean doesn't just hide things, it erases them with efficiency. Planes, ships, cities, creatures, entire coastlines vanish into water like they were never there, and the explanations range from scientific to please don't ask again. The Bermuda Triangle might be the most overhyped maritime riddle, but ships and planes really have vanished there, just not only there. The Devil's Sea off Japan has swallowed fishing fleets and military vessels for centuries. In 1952, the Japanese government declared a danger zone after 9 ships disappeared in 5 years. A research vessel was sent to investigate and also disappeared. Radio silence. Nothing recovered. countless ghost ships have drifted without crews. The Mary Celeste was found in 1872 floating intact in the Atlantic with cargo undisturbed, no signs of struggle, and lifeboats missing. The crew was never found. The MV Joyita disappeared in the South Pacific in 1955, with everyone gone and radios damaged but supplies untouched. Logs and charts were missing, as if someone took notes on vanishing and walked out the door. Then there are ships that sink without telling anyone why. The SS Waratah vanished off the coast of South Africa in 1909 with 211 people aboard. It was called the Titanic of the South, except Titanic at least left wreckage. Waratah left speculation. The Cyclops, a massive US Navy collier, disappeared in 1918 with 309 crew. It sent no distress call. It had no known enemies in the area. It left no debris. Its wreck has never been found. Storms, rogue waves, and mechanical failure explain plenty, but not everything. Rogue waves only gained scientific acceptance in the late 20th century, despite sailors describing them for millennia. These walls of water appear without warning, climbing 80 to 100 feet high and moving with enough force to snap freighters in half. Instruments on oil platforms and ships have recorded waves so tall they rewrite what engineers consider possible. The Dropner wave in 1995 hit a North Sea platform at around 85 feet and lasted seconds, long enough to scare the oil industry into updating survivability standards. The ocean floor hides things forever in sediment, trenches, and currents that scatter wreckage across miles. Even modern planes can disappear with shocking ease. Malaysia Airlines. Flight 370 vanished over the Indian Ocean in 2014. Satellite pings, current drift models, and debris fragments hint at a crash location, but the main wreck remains missing in a region deeper than Everest is tall. The deepest trenches are burial sites no human diver can reach unaided. Losing something there is indistinguishable from erasing it. Whole landforms have vanished too. Islands in the Pacific, charted in the 18th and 19th centuries, have since been undiscovered because cartographers recorded sandbars or pumice rafts that later broke apart or sank. Sandy Island, near Australia, was on maps for over a century before being proven non-existent in 2012. Waves and wind erase land the way time erases memory. Tsunamis have rewritten coastlines overnight. After the 2004 Indian Ocean tsunami, parts of Indonesia's shoreline shifted so dramatically that villages disappeared and new inlets formed where forests stood. Some islands lost so much land that maps needed updating. The ocean doesn't negotiate. If it wants new borders, it takes them. Underwater landslides trigger waves and swallow structures with no warning. The Storegga slide off Norway 8,000 years ago caused tsunamis that erased coastlines across the North Atlantic. Scientists believe similar slides still happen, triggered by gas hydrate shifts or quakes so deep no sensor catches them in time. Even sound sometimes vanishes things. In World War I and II, submarines disappeared without trace after internal explosions, hull failures, or collisions at depths where retrieval was impossible. Thousands of wrecks lie unrecovered. Some are only known because they stopped responding. Animal migrations vanish too. Sardine and herring runs that once filled seas for miles have blinked out in regions where currents warmed or oxygen dropped. Species move on. Populations collapse, food chains rewrite themselves. From the surface, someone says, they're gone. But the truth is, they moved somewhere no net or camera followed. The sea doesn't need magic to erase history. It has pressure, salt, darkness, movement, depth, silence, and time. Everything that disappears into it is either consumed, crushed, buried, or ignored until memory finishes the job. Long before submarines and satellites tried to dissect it, the ocean shaped the evolution of life in experiments that still echo across time. Every organism on land is basically a runaway descendant of something that crawled, swam, or drifted in salt water before deciding it hated gills. The ocean didn't just host evolution. It built the blueprint and then kept revising it for 3.5 billion years. Life started in the sea, not on land. The earliest cells formed around hydrothermal vents or shallow tidal pools where chemistry got reckless. Microbes learned to metabolize minerals, then sunlight, then each other. Bacteria invented photosynthesis and accidentally invented oxygen as waste, suffocating most anaerobic organisms and flipping the atmosphere into something new. The ocean took that oxygen, stored it, and let it react with iron until rust painted the seafloor red. Single-celled organisms turned into colonies. Colonies turned into experiments with symmetry, shells, and movement. Jellyfish and sponges might seem simple now, but they were cutting-edge prototypes when land was still lava and steam. Trilobites emerged in waves, armored like beetles mixed with Roombas, crawling across seafloors that would one day be the Rockies and Sahara. Fish evolved jaws, bones, and fins that eventually became the limbs of amphibians. Creatures like Tiktaalik and Ichthyostega hauled themselves out of prehistoric puddles millions of years before dinosaurs were a concept. Those early land animals still dragged marine biology with them. Water in cells, salt in blood, lungs built from swim bladders, hearts that once pumped for gills. Then came the ocean's villains and titans, ammonites with spiraled shells patrolling ancient seas, Dunkleosteus, the armored fish with a bite force to crack turtles that didn't exist yet, giant sea scorpions longer than humans, prowling shallow coasts like arthropod nightmares. When reptiles got involved, marine monsters upgraded the arms race. Mosasaurs, plesiosaurs, and ichthyosaurs hunted in oceans that made sharks rethink ambition. Some ichthyosaurs gave birth to live young at sea, evolving into fully aquatic reptilian torpedoes with built-in sonar. Whales began as wolf-like mammals that wandered into rivers and never came back. Over tens of millions of years, their legs shrank into flippers, nostrils migrated to the tops of their skulls, and tails flattened into horizontal rudders. Their ancestors walked on land, swam through swamps, then became giants singing across ocean basins. Today, blue whales outweigh any dinosaur by a factor of myth. Sharks predate trees, flowers, and most vertebrates. They've survived 5 mass extinction events, radiation bursts, asteroid winters, continental breakups, and climate shifts that erased 3/4 of life more than once. Their ancestors once had armor, then ditched it for speed and cartilage. Some had circular saw jaws. Others glided through prehistoric reefs shaped by corals now extinct. Extinctions didn't reset the sea. They rewrote it. After the end Permian extinction wiped out 96% of marine species, survivors rebuilt ecosystems with new rules. Coral reefs vanished and were replaced by sponge gardens and mollusk kingdoms until corals evolved back into the spotlight millions of years later. Each disaster forced oceans to reassemble themselves, and life obliged with weirder shapes every time. Even now, the ocean carries echoes of ancient designs. Horseshoe crabs bleed blue because their oxygen is carried by copper, a relic of ancient marine chemistry. They haven't changed much in over 450 million years and still spawn on beaches under full moons like tide-bound metronomes. Nautiluses glide through darkness, wearing shells nearly identical to their ancestors, living fossils with logarithmic spirals built into their architecture. Coelacanths, thought extinct since the dinosaurs, were rediscovered in 1938 by a stunned fisherman off South Africa. They swim with lobe fins that resemble proto-limbs, joints rotating like shoulders underwater. They don't care about extinction. They skipped evolution updates and kept going. Even humans still sound like the ocean when they break down. Tears, sweat, and blood all carry salt concentrations reminiscent of the seas that shaped our ancestors. The architecture of lungs and ears betrays aquatic roots. Embryos grow gill-like structures before developing into something else, as if biology still remembers the past even when the body forgets. The land acts like it owns life, but everything that crawls, flies, walks, or speaks was built by water first. The ocean was the first home, the first battlefield, and the first graveyard. Land is a lease. The ocean is inheritance. Even after life swarmed the land, the ocean kept reinventing evolution in waves. Every extinction, migration, and mutation on land had roots anchored in saltwater, because the sea doesn't let go of what it starts. It just rearranges it with pressure, depth, and time. Take giant marine reptiles. When dinosaurs ruled land, mosasaurs ruled the water. These were not overgrown lizards on vacation. They were apex predators, stretching up to 50 feet long, with double-hinged jaws and backward-curved teeth designed to drag prey into darkness. Ichthyosaurs evolved into sword-faced, dolphin-shaped monsters with eyes the size of dinner plates to hunt in depths where light was a rumor. Plesiosaurs swam with flippers like wings, their long necks allowing stealth strikes that made entire shoals disappear. After those beasts vanished, sharks and whales inherited the oceans like rival dynasties dividing empires. Megalodon showed up and reminded the planet that the sea still writes horror. Estimates put it at up to 60 feet long, with teeth the size of human hands and bite force strong enough to crush bone into jelly. Its jaws could swallow seals whole and bite whales in half. It hunted across oceans until cooling waters, changing prey, or competition with early orcas pushed it into extinction or into deeper water where cameras can't follow. We don't know, and the ocean isn't answering. Whales, too, became evolutionary flexes. Basilosaurus, despite the name, wasn't a reptile. It was a prehistoric whale stretching over 50 feet, serpent-like and built for ambush. It still had vestigial hind limbs sticking from its torso, like reminders of landlocked ancestry. Later, baleen whales filtered entire clouds of krill through mouth bristles, while toothed whales evolved sonar and tactical hunting strategies. Orcas developed cultural hunting traditions. Some beach themselves to grab seals, others flip ice floes, others chase sharks and rip out their livers with surgical precision. And while land animals changed shapes, most ocean life just upgraded or downsized. Crabs reshaped themselves into dozens of forms so many times that scientists coined the term carcinization, evolution's bizarre habit of turning unrelated creatures into crab-shaped solutions. It happened to lobsters, shrimp, and even some extinct lineages. When in doubt, evolution picks crab like its clicking default settings. Cephalopods, octopuses, squid, cuttlefish became some of the most advanced invertebrates to ever exist. Octopuses can solve puzzles, escape aquariums, open jars, mimic textures, and change color in milliseconds using chromatophores and papillae. Some species use coconut shells as armor. Others shapeshift to impersonate venomous animals they've never met. Their ancestors filled prehistoric oceans with shell-armored nautiloids longer than humans. Reef ecosystems turned into evolutionary factories. Coral polyps, tiny as sand grains, built sprawling cities of calcium carbonate over thousands of years, attracting fish, crustaceans, worms, mollusks, and predators that evolved colors and shapes to match the scenery. Some reef fish change sex when needed. Others mimic harmless species to sneak up on prey. Leafy sea dragons evolved fronds that make them indistinguishable from seaweed, while frogfish developed the ability to walk along the seafloor and use lures growing from their heads. Even the smallest players shaped life. Plankton, Drifting plants and animals too tiny to admire fill the ocean with invisible wars and alliances. They generate most of the planet's oxygen, feed everything from shrimp to whales, and bloom in colors visible from space. Diatoms, with glass shells made from silica, drift like jeweled spores. Radiolarians build crystal lattice skeletons that fall to the seafloor and form entire sediment layers. These microscopic architects have been engraving the planet since before vertebrates evolved brains. When animals left the sea, they took ocean designs with them. Amphibians kept wet skin, reptiles retained salt glands, birds held onto hollow bones and waterproofing. Mammals carried milk and brain chemistry tuned by ancient tides. Even human circadian rhythms sync to 24-hour cycles shaped by rotation over oceanic surfaces. The moon still pulls the fluids inside our cells, the same way it pulls the tide. But the ocean didn't stop reclaiming what wandered off. Birds like penguins, puffins and cormorants dove back in. Seals traded legs for flippers, keeping lungs and fur but surrendering land speed. Sea snakes adapted to breathe air while living submerged for hours, storing oxygen in blood and muscles. Marine iguanas in the Galapagos learned to graze algae off rocks underwater. Crocodiles stalk mangroves and brackish deltas, waiting for mammals too confident to realize water remembers. Life didn't just emerge from the ocean. It keeps crawling back to it. Every time the land proves unstable, through heat, scarcity, or extinction, water absorbs the refugees and retools them. The sea is the original lab, museum, graveyard, and launch pad in one. Humans act like they discovered the ocean, but the moment they touched it, the water made it clear who was visiting and who was permanent. Every attempt to map, conquer, or mine the sea has been a combination of ambition, arrogance, and panic management. Even now, with satellites, sensors, and submersibles, more than 80% of the ocean floor remains unexplored. The parts that are documented were mapped with technology originally meant for war, not curiosity. The first divers weren't scientists or thrill seekers. They were hunters and salvage workers holding their breath for pearls, sponges, and sunken goods. Indigenous freedivers in the Pacific, Mediterranean, Caribbean, and Indian Oceans harvested resources from depths that would make modern snorkelers tap out in 30 seconds. The Bajau people of Southeast Asia can hold their breath over 13 minutes and dive more than 200 feet because their spleens have adapted over generations to release extra oxygenated blood on command. Ancient civilizations learned the sea by fear and necessity. The Phoenicians, Polynesians, and Indonesians crossed entire oceans using stars, currents, birds, and swell patterns. They navigated without compasses centuries before Europe realized Earth had more water than ego. Polynesian voyagers read wave reflections off invisible islands, charted wind belts from instinct, and memorized entire archipelagos before maps existed. They reached Hawaii, New Zealand, and Easter Island using only knowledge passed through chant and story. Later, colonizers and traders crossed the Atlantic and Indian Oceans not because they understood the water, but because profit demanded it. They lost ships routinely, mistook currents for fate, and named places after themselves like the sea was flattered. Cartographers drew monsters on maps to label ignorance. Even now, nautical charts have blank spaces, trenches without names, and depths recorded as guesses. Then came submersibles and sonar. The first crewed descent to the deepest point on Earth, the Mariana Trench, happened in 1960 when Jacques Picard and Don Walsh took the bathyscaphe Trieste down to nearly 36,000 feet. The windows cracked from pressure on the way down, and they landed in silt that erupted like smoke. They stayed 20 minutes, saw a flatfish-like creature no one's identified since, and returned before the ocean changed its mind. James Cameron went back in 2012 like he was scouting a movie set. His solo descent took him into the trench again, and he found shrimp-like amphipods and microbial mats clinging to rocks, thriving in silence and crushing weight. Since then, only a handful of people have reached those depths. More humans have walked on the moon than visited the deepest ocean. Robotic explorers do the rest. ROVs and AUVs film landscapes of hydrothermal chimneys, methane vents, trenches, abyssal plains, and volcanic ridges. They find creatures so strange that taxonomic teams argue over whether they're new phyla or hallucinations. Cameras capture glowing worms, transparent fish, and coral forests older than cities. Then the footage ends when something bumps the fiber cable, and everything goes dark again. Mining companies now want to strip the deep sea for cobalt, manganese, nickel, and rare earth metals in polymetallic nodules scattered across abyssal plains. These nodules form over millions of years, growing slower than fingernails, and host ecosystems no one has catalogued. Governments and corporations slobber over them like toddlers reaching for candy, claiming it's essential for green energy tech, while ignoring that destroying deep habitats could erase entire species humanity never met. Fishing fleets scraped the ocean long before they bothered counting what they took. Industrial trawlers drag weighted nets across the seafloor, tearing coral structures and sponge communities apart in seconds. Some nets rake canyons deeper than skyscrapers are tall. Shrimp trawling alone kills 6 to 20 pounds of bycatch per 1 pound of shrimp. Everything else, turtles, fish, sharks, rays, is tossed overboard dead or dying. Even scientific research accidentally harms what it studies. Expeditions drop instruments that break, leak, or vanish. Submersibles crush habitats with thrust awash. Sample collectors remove species that might have been the only individuals in existence. The deep isn't empty. It's just out of reach long enough for humans to assume nothing breaks when touched. The irony is that even with satellites mapping sea surface height and temperature changes across the globe, most of the ocean's shape is still a mystery. Seamounts remain uncharted. Canyons hide wrecks and species with no names. The majority of underwater volcanoes have never been filmed erupting. The ocean keeps its secrets the same way it keeps its bones, buried, pressurized, and uninterested in confession. The deeper humans go, and the more they take, the clearer it becomes that the ocean doesn't bend to ownership. Every attempt at control exposes how little we understand the systems we're scrambling to extract from. The ocean isn't just water. It's chemistry, pressure, life, death, memory, and consequence layered in blue. The deep sea is the largest habitat on the planet, and we know almost nothing about it. Below 650 feet, sunlight dies. Below 3,300 feet, pressure crushes anything not built to withstand it. At the bottom of trenches like Mariana, pressure exceeds 16,000 pounds per square inch, enough to collapse submarines, implode cameras, and turn metal into folded wreckage. Yet life persists there in forms that laugh at physics. Amphipods with aluminum in their shells, snailfish with gelatin bodies, and bones so soft they wouldn't survive at the surface. Hydrothermal vents host entire ecosystems powered not by sunlight, but by chemosynthesis. Worms with no mouths, no stomachs, just symbiotic bacteria turning volcanic chemicals into energy. Giant clams glow under thermal plumes. Crabs covered in hair-like filaments farm microbes on their claws. These oases sit in pitch darkness around superheated fluid jets that can reach 700 degrees Fahrenheit, yet life flourishes in a chemistry lab humans still haven't reverse-engineered. Cold seeps, places where methane and hydrogen sulfide seep from the seafloor, support fields of tube worms and mussels that live for centuries. Carbonate reefs grow on the backs of chemical reactions entirely separate from sunlight-based ecosystems. When researchers sample these places, they take fragments back to labs where most of the organisms die because their world is made of pressure and chemistry Earth's surface can barely simulate. Then there's the Hadal zone, anything below 20,000 feet, spread across trenches deeper and longer than mountain ranges. Life there includes translucent snailfish with antifreeze-like proteins, amphipods as large as hands, and microbial mats feeding on decaying matter raining down like snow from the upper ocean. Bones of whales and fish fall, and whole communities called whale falls bloom on carcasses for decades, cycling nutrients in silence no one sees. The ocean is also the largest carbon cemetery on Earth. When plankton die, their remains drift downward, forming marine snow that feeds deep ecosystems and locks carbon away for centuries. Coral skeletons, mollusk shells, and foraminifera deposits create vast layers that act as geological libraries. Every inch of seafloor sediment records eras of temperature, extinction, and climate swings more accurately than archives on land. Humans think exploration is progress, but even mapping is incomplete. The majority of seafloor maps come from satellite altimetry, indirect measurements of sea surface height that infer the shape of the bottom. The resolution is so low that mountains taller than Everest could hide in trenches without a red flag. Only a fraction has been mapped with sonar at high resolution, and most of that belongs to military archives no one else sees. Despite that ignorance, extraction escalates. Deep-sea mining plans target the Clarion-Clipperton Zone in the Pacific, an area as large as the continental United States. Companies want to vacuum the seafloor for nodules and leave behind plumes of sediment that could smother life over hundreds of miles. Scientists warn that damage could last millennia. Companies reply with feasibility assessments written like job applications from bulldozers. Meanwhile, coastal waters serve as dumping grounds. Oil rigs leak. Chemical plants discharge waste through offshore pipes. Warships scuttle munitions in deep canyons and call it disposal. Radioactive barrels sit in trenches with no labels left. Sunken submarines still leak fuel and toxins decades after sinking. The ocean absorbs everything until it doesn't. Even light pollution reaches the sea. Surface glow from cities disrupts turtle hatchlings and seabird navigation. Noise pollution interrupts communication across entire species. Heat from climate change alters currents and kills coral before researchers finish their grants. Microplastics sink into the deepest trenches and lodge inside amphipods that evolved before mammals existed. The ocean gives everything and asks nothing except that you don't break what you don't understand. But humans break by default, then draft treaties after the damage lands on headlines. Even international waters, areas beyond national control, are governed by loopholes pirates in suits exploit. Still, for every disaster humans cause, the ocean outlasts. It erases footprints, it hides wrecks, it absorbs poisons, it reclaims coastlines, it redraws maps without permission. Whether life continues with us or without us isn't its concern. The sea existed before our languages named it, and will exist long after our last satellite blinks out over a warming tide. People love to imagine the ocean as a warm, swimmable postcard, but half of it is colder than a morgue drawer and darker than a power outage in space. Temperature doesn't just fluctuate, it divides the ocean into invisible layers that decide who lives, who dies, and who drifts frozen for eternity. The surface is where tourists float, storms brew, and sunlight bullies plankton into photosynthesis. But even there, temperature changes shape everything. Tropical waters hover around 80 degrees Fahrenheit or higher, letting coral reefs and mangroves thrive, at least until heat waves bleach them into ghost structures. Temperate zones swing between warm summers and cold winters, shuffling fish migrations like deck chairs in a storm. In polar regions, the surface can freeze into sea ice, trapping air bubbles that sound like crackling fires when they shift. But go deeper, and the world drops off fast. The thermocline, a sloped boundary where temperature plummets from warm to icy, is the ocean's unmarked border between familiar and alien. In many regions, you only need to descend a few hundred feet before the water chills into the 40s, 30s, then colder. Sunlight can't punch past the upper layers, so heat stays shallow, while cold water, dense and ancient, lingers beneath like a memory of past winters. Below 3,000 feet, the ocean becomes the abyssal zone, where temperatures stabilize around 35 degrees Fahrenheit. It's not freezing, but close enough that anything not adapted to it dies slow. Fish here have antifreeze proteins in their blood, metabolic rates slower than clocks, and muscles so soft they'd collapse under their own weight on land. Some carry internal lights to navigate, hunt, or attract prey because there's no sun to cast a shadow. In the Hadal zone, trenches and deep valleys, the cold clings harder and pressure pushes temperatures into narrow ranges that barely shift over centuries. Beneath Antarctica, supercooled brine forms brinicles, underwater icicles of salt water that sink from sea ice and freeze anything they touch. Time-lapse footage shows starfish and sea urchins dying in place as brinicles crawl across the seafloor like icy tentacles. Marine mammals survive the cold with blubber thick enough to embarrass insulation manufacturers. Whales store heat in fat layers and countercurrent blood systems that recycle warmth through arteries and veins like built-in radiators. Seals sleep under ice sheets. Walruses use folds of fat like armor. Polar bears swim miles through Arctic water that would shut a human body down in minutes. Penguins huddle in circles so tight you could stack drinks on them without spilling. Humans, on the other hand, don't belong in cold water. Without wetsuits or gear, hypothermia starts within minutes in 50-degree Fahrenheit water. At 40 degrees Fahrenheit, limbs go numb so quickly that even Olympic swimmers sink. At 32 degrees Fahrenheit, cold shock alone can stop a heart. Titanic survivors in the North Atlantic died not because they drowned first, but because the cold ate through nerve and muscle faster than rescue could arrive. Temperature changes also carve migration patterns. Species like salmon and tuna follow precise thermal corridors across oceans, and when the water warms unnaturally, they divert into unfamiliar territories, fueling competition, collapse, or boom in the wrong places. Lobsters are abandoning southern New England and heading north as waters warm. Cod are retreating into deeper layers to find the cold they're built for. Heat doesn't stay put. Currents move it. The Gulf Stream carries tropical warmth to the North Atlantic, moderating European climates. The California Current and Humboldt Current bring cold water up coasts, feeding plankton blooms and cooling entire weather systems. El Niño and La Niña events happen when the Pacific shifts its thermal balance, triggering droughts, floods, and storm disruptions across continents. Some of the coldest, densest water on the planet forms in Antarctica. When sea ice freezes, it leaves salt behind, creating brine-heavy water that sinks and crawls across the seafloor for thousands of miles, circulating nutrients and regulating global temperatures. Climate change threatens to slow this deep water formation, which could disrupt oxygen supply across the planet's largest habitat. Temperature also decides where coral lives and dies. Most reef-building corals can only tolerate a narrow band around 73 to 84 degrees Fahrenheit. Anything hotter forces them to expel their symbiotic algae, turning them white and starving them. One prolonged marine heat wave can kill centuries of reef growth in weeks. Even so-called cold water corals exist. Some thrive in darkness and frigid temperatures miles below the surface, building reefs no eye will ever see unless a submersible stumbles into them. The ocean doesn't need fire to burn. It uses cold just as brutally. It freezes, slows, cracks, preserves and silences. To land life, temperature is weather. To the ocean, it's law. If temperature decides who can move, pressure decides who can exist at all. Humans think space is extreme, but the deep ocean crushes harder, faster, and with less forgiveness than the vacuum above the atmosphere. For every 33 feet you descend, pressure increases by about 1 atmosphere. At the surface, that's just air. At 1,000 feet, it feels like an elephant standing on every square inch of your body. At 36,000 feet in the Mariana Trench, the weight equals about 16,000 pounds per square inch, more than enough to crumple steel like damp cardboard. Creatures down there don't fight pressure, they surrender to it. Deep-sea animals evolved bodies without air pockets. No lungs to collapse, no swim bladders to implode, no rigid bones to snap. The iconic blobfish looks like a gelatinous cartoon villain when hauled to the surface because it's built for pressure, not gravity. At its natural depth, it's a functional predator, not a meme. Some fish have flexible cartilage instead of bone, and their cells contain special molecules called piezolites that prevent proteins from folding under pressure. Jellyfish, siphonophores, and salps drift with bodies more water than flesh, moving through the abyss like ghosts wearing muscle. Amphipods at trench depths have aluminum compounds in their shells, extracted from surrounding sediment to stabilize their structure. Nothing about these organisms would survive at the surface because evolution optimized them for weight, not air. Humans cheat with engineering. Submarines and research vessels use titanium, steel, syntactic foam, and sphere-shaped cabins to resist collapse. Even then, one structural flaw means instant implosion. No water leak, no alarm, just immediate obliteration. The Trieste, Deep-Sea Challenger, Limiting Factor, and a few others are built like armored diving bullets. Submersibles don't open windows at depth. Ports are tiny, layered acrylic or quartz designed to survive the squeeze. Jacques Piccard and Don Walsh heard the hull of the Trieste groan and crack during their 1960 descent into the Mariana Trench. They stayed anyway. James Cameron later described the deep-sea world as alien and quiet, but only because you can't hear the ocean trying to kill your machine. Pressure also shapes geology. Underwater mountains, trenches, faults, and volcanic ridges form under forces continents don't endure. The seafloor spreads at mid-ocean ridges, pushing magma into water where pressure suppresses explosive force. Hydrothermal vents spit mineral-rich fluids that would vaporize at the surface but instead mix into the deep like ink in chilled oil. Some volcanic eruptions happen so deep that pressure stops bubbles from expanding, turning what would be a firestorm on land into a silent exhale of lava that chills into pillow-shaped basalt. These pillow lavas form vast underwater landscapes that look like stacked dragon eggs abandoned in the dark. Even sound changes under pressure. It travels faster, farther, and in curved paths. In the Sofar Channel, a layer of water where pressure and temperature combine to carry sound efficiently, whale calls and submarines can be heard across entire ocean basins. The US Navy exploited this for surveillance long before marine biologists used it to study migration. Explosions behave differently too. Detonations at depth produce shockwaves that travel for miles and stun or kill anything nearby. Pressure changes from human-made blasts can burst organs in creatures that never evolved to escape sound traveling 5 times faster than in air. Marine mammals face pressure differently. Whales collapse their lungs on deep dives to prevent nitrogen absorption and avoid the bends. Their rib cages fold inward, and oxygen gets stored in blood and muscle rather than air spaces. Sperm whales dive past 6,000 feet chasing squid, holding their breath for up to 90 minutes with hearts that slow to conserve energy while under force that would crush submarines from the 1960s. Even shallow diving animals have limits. Dolphins risk embolisms if startled during ascents. Sea turtles can suffer decompression when trapped in nets. Some seals collapse lungs naturally, but still avoid depths where pressure outpaces instinct. For humans without gear, diving deep means popping eardrums at a few yards if you don't equalize properly. At 200 feet, nitrogen narcosis can scramble your brain. Past 300 feet, blackout and death become likely without mixed gas training and equipment. Free divers push to 400 feet or more, riding weighted sleds, but even they respect their limits because consciousness is optional when pressure rises. Pressure doesn't shout, it waits, and everything in the deep either adapts to its grip or disappears before being discovered. The ocean isn't empty below. It's just occupied by life, shaped into silence by physics that don't negotiate. Light doesn't just fade in the ocean, it dies in layers. Sunlight penetrates only the first 200 meters or so, a region called the euphotic zone. That's where photosynthesis happens, where plankton bloom, where fish still have color, and where coral reefs stage their shimmering nightlife. But even there, the light is filtered. Reds vanish first, then oranges, then yellows. By the time you're a few dozen feet down, blue and green are the last survivors, which is why the ocean doesn't look like fire or blood. It eats those wavelengths on contact. Below that is the dysphotic zone, the twilight band between roughly 200 and 1,000 meters. Light bleeds into gloom. It's not dark enough for total blindness, but not bright enough for plants to grow. Shapes are silhouettes, colors flatten. Eyes grow bigger or vanish entirely depending on the species. Predators stalk with sensitivity tuned to flickers, glints, and shadows. Fish develop reflective sides, red skin that appears black, or transparent flesh to avoid being seen. Descend past 1,000 meters and you enter the aphotic zone, the midnight realm where sunlight is a rumor. Here, darkness is not just absence, it's habitat. Creatures don't expect light, so they make their own. Bioluminescence rules the deep. Anglerfish with glowing lures, lanternfish with light organs lining their bodies, comb jellies whose cilia scatter iridescence like oil slicks in motion. Shrimp release glowing clouds to distract enemies. Squid flash patterns to communicate or blind threats. Some sharks glow under their bellies to erase their silhouette from prey below. Bioluminescence isn't rare. It's the norm. Up to 90% of deep-sea organisms produce light in some form. Some host symbiotic bacteria to power their glow. Others create chemical reactions using luciferin and luciferase. The light shines cold, efficient, and deliberate. It attracts mates, lures food, startles predators, or camouflages by counter-illumination. Even stranger, many deep species see light in spectrums humans don't. Some fish detect ultraviolet or near-infrared glows. Certain dragonfish emit red bioluminescence invisible to most prey, giving them sniper vision in total blackness. Transparent fish like barrelies point their tubular eyes upward through fluid-filled shields, scanning for prey outlined faintly against the last traces of light filtering from above. At these depths, you don't evolve based on speed or strength first. You evolve based on what you can detect in a world that doesn't want you to see. Some animals have no eyes at all and use lateral lines, vibration sensors, or electroreception to find prey. Others have eyes so sensitive they reflect light like mirrors, catching even the bioluminescent speck of a distant organism. Surface dwellers assume darkness means emptiness. It's the opposite. The deep ocean is packed with life because darkness protects more than light does. No sunlight means stable temperatures, ancient lineages, and ecosystems that change only when the planet forces them to. The aphotic zone holds species older than mountains, drifting in currents older than civilizations. Humans use light to explore where their bodies can't go. Submersibles carry floodlights that carve tunnels through black water, but the moment a vehicle turns its beams off, visibility collapses into ink. Cameras reveal organisms that look like hallucinations. Fanged eels with glass jaws, translucent octopuses, jellyfish with lights pulsating like alien Morse code. Once the lights shut down, they vanish into the dark like illusions reclaiming themselves. Even war relied on this absence of light. Submarines vanish without trace under thermal layers where sonar skips or bends. Special forces trained to navigate by feel in black water. Lost wrecks stay lost because the deep swallows not just vessels, but sight itself. And when light does show up naturally, it looks supernatural. The Milky Sea phenomenon, vast stretches of the ocean glowing blue or white, has been recorded by ships for centuries, but only recently confirmed by satellites. Bacterial bioluminescence spreads across tens of thousands of square miles, turning waves and wakes into ghost light. Sailors described it as sailing on stars or entering another world. They weren't exaggerating. Lightning over the surface lights up the top layer in flashes barely reaching below. Volcanic eruptions under the sea make lava glow briefly before darkness swallows it. Meteors falling into water burst into fireballs against night horizons and disappear in steam and silence. But the deepest dark doesn't fear fire or moonlight or stars. It folds around everything that enters and waits for pressure, gravity, or hunger to take over. Light is optional at the bottom of the world. Darkness is permanent, and life knows how to wear it. Vision is a luxury in the ocean, and the deeper you go, the less it matters. Even near the surface, many animals rely on senses humans don't possess or understand, because eyes are only useful when light cooperates, and the ocean doesn't guarantee that past breakfast depth. Sharks sense the world like living antennas. Along their snouts and heads are electroreceptors called ampullae of Lorenzini, gel-filled pores that detect the faint electrical signals of beating hearts, moving muscles, even the bioelectric hum of buried prey. They don't need to see you to know you're swimming. They can feel you from meters away through voltage changes too small for instruments to measure. Some rays and skates navigate by Earth's magnetic field the way birds follow constellations. Fish use lateral lines to sense pressure waves and movement. Tiny hair cells in fluid-filled canals detect vibrations in the water, revealing predators, obstacles, and currents even in pitch black. Schooling fish move as one because they feel each other's micro-movements like silent choreography. A shoal isn't a group, it's a single organism made of dozens of bodies reacting in tandem to pressure signals swirling like wind through grass. Sound replaces vision as the dominant sense underwater. It travels 5 times faster in water than air and over far longer distances. Blue whales can communicate across basins, their calls dropping into infrasonic frequencies that circle the globe. Some snapping shrimp colonies are so loud they drown out sonar, reefs full of crackles that sound like bacon frying in the void. Fish grunt, drum, click or croak to court, warn or coordinate. Scientists used to think the ocean was mostly silent. Now they know it's noisier than most forests, just on wavelengths humans don't catch unless they drop a hydrophone. Odor is another invisible map. Salmon smell the chemical signature of the river they were born in and travel thousands of miles through saltwater and currents to return to the exact stream where they'll spawn and die. Crabs detect molecules of decay or drift algae from incredible distances and scuttle toward meals as though pulled by thought. Octopuses taste with their suckers, every arm covered in sensory cells, analyzing chemical cues and texture in real time. Some animals build senses on light humans don't see. Mantis shrimp can detect ultraviolet, polarized light, and spectral shifts we don't have words for. They don't just see color, they see gradients in ways researchers still haven't decoded, using hyperspectral vision to spot prey, mates, and threats hidden in wavelengths invisible to most life. Others evolved to navigate darkness in microscopic increments. Deep-sea dragonfish have stealth vision, retinas tuned to red bioluminescent light they produce themselves. Most deep creatures can't see red, so dragonfish effectively carry sniper-scope flashlights in a world of permanent night. Cephalopods don't see like humans. They detect polarization, contrast, and shape, even if their color vision is limited or absent. Yet they change color, pattern, and texture with terrifying accuracy. Their skin is smarter than their eyes, reading light conditions through photoreceptive cells built directly into their flesh. Octopuses can camouflage against rocks they've never seen before by sensing light around their bodies, not just through their eyes. Even jellyfish feel the world. They lack brains but navigate with nerve nets that sense gravity, current, and contact. Box jellyfish have eyes, 24 of them in fact, clustered in sensory organs that let them avoid obstacles and hunt fish, despite having no central brain to interpret sight in human terms. Sperm whales map the dark with echolocation clicks so loud they can stun prey. Their massive heads are sound cannons, using air sacs and oil chambers to focus sound into a weaponized beam, then read the echoes with precision better than most sonar arrays. Dolphins do the same on smaller scales, detecting air cavities in fish or locating buried shells through sound alone. Even plankton respond to chemical trails, temperature gradients, and turbulence. They migrate vertically every single day, rising thousands of feet at night to feed near the surface, then sinking back into darkness at dawn to avoid being eaten. It's the largest daily migration on Earth, and most of it happens in blackness. And where senses fail, the ocean itself guides. Magnetic fields steer turtles across oceans to the beach of their birth. Humpback whales follow temperature bands and gravity cues. Eels spawn in the Sargasso Sea, then vanish into rivers and estuaries with no visible map or compass. The darkness of the deep doesn't create absence. It creates specialization. Evolution doesn't care about sight when pressure, current, chemistry, sound, and electricity reveal more. Humans call it darkness because their eyes shut down. Everything else calls it home. For all the facts, fossils, legends, and warnings, the ocean remains the only thing on this planet that can exist with or without us and not care either way. It doesn't need saving. It needs surviving. Humans scramble to petition, protest, and propose regulations that arrive decades after damage becomes inheritance, but the water doesn't operate on human urgency. It moves in cycles so large, entire civilizations look like footnotes in its weather. Every drop carries memory. The salt in the water is older than bones. The trenches hold carcasses that fell before mammals existed. Coral reefs grow on the skeletons of their ancestors, layer upon layer of time hardened into architecture. Whale songs drift through thermoclines like messages stored in moving vaults. The ocean doesn't forget, it absorbs. But what it absorbs now is chaos. Overfishing isn't depletion, it's erasure. Tuna populations have crashed by 90% in the last century. Sharks die by the tens of millions every year for soup, fear, and bycatch. Trawlers strip seafloors like bulldozers dragged through cathedrals. Coral reefs bleach and crumble. Ice sheets fracture and bleed meltwater faster than models predicted. Microplastics reach the bottom of the Mariana Trench and the inside of human bloodstreams for good measure. People talk about protecting the ocean as though it's a single meadow or park. It's 70% of the planet and 99% of livable space by volume. Most of it is unseen, unstudied, ungoverned. Even marine protected areas often ban nothing but paperwork. Illegal fishing fleets operate with lights off, names scraped off hulls, and GPS trackers disabled. Nations argue over seabed rights, while deep ecosystems older than language get vacuumed for cobalt and manganese like loose change. Yet the ocean still performs the labor of a god. It absorbs heat no atmosphere could tolerate. It swallows a third of human carbon emissions every year. It turns storms into circulation. It builds rain. It oxygenates air. It holds more biodiversity than all forests combined. It feeds billions even as fisheries decline, and instead of reverence, it gets garbage, oil spills, mining permits, and sonar blasts. When it does react, people call it disaster, as though the ocean is punishing instead of responding. Hurricanes intensify over warming water and rip apart coastlines built grinning at the tide. Storm surges reclaim wetlands paved into hotel foundations. King tides flood neighborhoods designed by developers who assumed the sea respected fences. Entire communities talk about rising water as if it's new when the ocean has always taken back what land borrowed. And still, there's no finality in its anger. Life reforms in places humans have already written off. Sunken ships become reefs. Marine preserves rebound faster than models predict when left alone. Mangroves return if coastlines stop bulldozing them. Whale populations rebuild when harpoons stop firing. The ocean isn't fragile, it's interrupted. What dies doesn't return, but what survives adapts. Humans are the only species arrogant enough to think dominion is permanent. The ocean has erased empires without lifting a wave. It swallowed Doggerland, erased coastlines of ancient Greece, flooded the Black Sea basin, and drowned forests now preserved as peat beneath silt. The next century won't be the first time water redrew borders. It will just be the first time the architects noticed too late. Even if the worst predictions unfold, ice sheets collapsing, currents stalling, fisheries collapsing, reefs gone, coasts drowned, the ocean will continue its physics. Currents will reroute, new species will evolve, old ones will vanish unseen, trenches will fill with new debris, volcanic ridges will keep widening the floor, hydrothermal vents will spit new life into the abyss. The question isn't whether the ocean will survive. It's whether humans will survive what the ocean becomes in response to us. The ocean was here before breath, before continents, before light touched land. It didn't wait for humans to name it, map it, or fear it. It didn't need worship or language. It simply existed, a force, a cradle, a graveyard, a mirror of time. Everything that crawls, walks, flies, or speaks came from it, and everything that dies eventually cycles back through its chemistry. Humans stand at the edge of it like they're separate from it, like they're visitors instead of escaped residents with salt still in their veins. Cities pretend the horizon is a boundary instead of a prediction. Glass towers face the tide with their backs to the past, building boardwalks and ports on borrowed ground as though treaties matter to tide lines. But the water doesn't negotiate. It's already in the air, in the lungs, in the crops, in the storms, in the blood. It's under ice sheets, inside fault lines, wrapped around mountains buried miles beneath the surface. It is every disaster and every cure, depending on what it's forced to carry. There is no version of the future that excludes the ocean. It will rise, shift, acidify, overheat, or overturn if pushed far enough, and everything built on denial will collapse before it changes course. Concrete won't hold it back. Money won't bribe it. Politics won't distract it. It doesn't punish, it equalizes. But acknowledgement isn't surrender. The ocean doesn't need saving from itself. It needs release from interference. Leave a reef alone and it rebuilds. Stop trawling a floor and species return. Halt seismic blasting and whales sing in frequencies that carry for miles again. Ban plastic waste and coastlines breathe without choking. Marine preserves, enforced and respected, turn dead zones into sanctuaries within a decade. The water isn't waiting for miracles. It's waiting for humanity to get out of its way. People forget the ocean doesn't end at the shore. It rises into clouds, falls as rain, feeds rivers, and seeps into soil. Its chemistry determines the oxygen count in every breath. Its currents influence every storm. Its plankton regulate the carbon in the sky. Its heat decides which coastlines survive another generation. Every drought, wildfire, flood, harvest, and migration has saltwater fingerprints. And still, in all its magnitude, it gives moments of peace to creatures dumb enough to think they're unconnected. Waves erase footprints. Tides carry driftwood, shells, and bones alike. The surface glitters like sky shattered into motion. Even in its most violent moods, there's a rhythm older than survival. Humans stare at it for comfort without knowing why. Maybe it's memory recognizing origin. Maybe it's awe pretending it's curiosity. No one will ever finish discovering the ocean. By the time a trench is mapped, another shoreline will break apart. By the time a species is named, another will die unseen. By the time a law is written, another ecosystem will be gone or reborn without permission. Exploration is not conquest. It's a glimpse through a keyhole in a world too vast to archive. One day, the last shipwreck of this era will settle into silt beside the bones of whales and ruins of older ages. Fish will weave through its beams. Coral will anchor to the rust. Sediment will turn metal into memory. The surface will forget the name of the vessel long before the bottom does. The ocean doesn't care about legacy. It is legacy. It doesn't belong to humanity. Humanity belongs to it, even when it pretends otherwise. And when the last voice falls quiet and the last map fades, the tide will still move in and out like it always has, unbothered, unbound, and eternal. Entire nations face erasure. Tuvalu, Kiribati, the Maldives, and the Marshall Islands are not debating if, but where to go. Some are buying land in other countries. Others plan to become digital nations when their physical territory submerges. Their history, cemeteries, and villages will end up on the seafloor, archived in salt instead of soil. Cities don't escape either. Lagos, Mumbai, New Orleans, Bangkok, and Jakarta sit in zones where tides and rainfall combine like conspirators. Jakarta is sinking so fast, the Indonesian government is relocating its capital to another island. New York builds surge barriers as though hurricanes sign contracts. London's Thames barrier was designed for occasional use. Now it closes multiple times a year. Coastal aquifers drink seawater when the pressure difference shifts. Crops die from the roots up. Wells turn brackish. Farmland becomes salt flats that no desalination plant can revive cheaply. Drinking water systems fail not with waves, but with invisible intrusion. The ocean seeps in through soil and pipes long before anyone sees flooding. Even places far inland aren't safe from rising seas. Rivers back up with higher tides, flooding towns with no coastline. Estuaries expand. Wetlands drown. Species retreat or vanish. Stormwater systems built for last century's rainfall choke on this century's sea level. The shoreline was never fixed. Maps lied for convenience. The ocean always redraws borders with or without permission, and the redraw has already started. For all the ways the ocean erases, it also reveals. When shorelines retreat or sea levels drop temporarily, they uncover pieces of history no museum could have preserved better. Storms rip sand from coasts and expose shipwrecks buried for centuries. Droughts lower water tables and unearth forests that once stood before the sea claimed them. The ocean doesn't care about archaeology, but it stores humanity's lost chapters like sedimentary confession. In Wales and England, storms peeled beaches back to reveal prehistoric forests. tree stumps still rooted where humans hadn't yet built names for gods. On the coast of India, fishermen reported stone structures beneath the surf near Mahabalipuram. After the 2004 tsunami pulled water out before roaring back, entire temples were exposed on the seabed, confirming myths locals had passed down for generations. Doggerland, once a land bridge connecting Britain to mainland Europe, now lies drowned beneath the North Sea. Fishermen still drag up mammoth bones, antler tools, and human artifacts from an era when the channel was grasslands and rivers. Rising seas swallowed it around 8,000 years ago, erasing not just territory, but memory. Today, wind turbines stand where families once hunted and buried their dead. The Black Sea hides ruins of ancient settlements beneath its anoxic lower layers where oxygen never reaches and decay slows to a crawl. Shipwrecks there remain intact with masts, ropes, even carvings preserved. The seafloor acts as a vault, not a grave. Every drowned port city, collapsed quay, or sunken barge lies there waiting for submersibles and cameras to confirm what legends only whispered. Wrecks become artificial reefs, whether intended or not. The Titanic rests under 2.5 miles of water, its metal bones colonized by extremophile bacteria and odd coral formations. The Andrea Doria, Lusitania, and dozens of warships are being slowly eaten by salt and life. Aircraft from World War II still lie intact in the Pacific, engines quiet, fuselages draped with sea fans and anemones. Entire fleets vanished beneath waves in storms and battles. The Spanish Armada left shipwrecks along British coasts that surfaced during erosion events. The Pacific holds sunken graveyards of war machines, the ruins of the Battle of Midway, the Fleet Cemetery at Chuk Lagoon, scuttled carriers, destroyers, and submarines. Metal rots, but frameworks endure, populated by fish that ignore names like Bismarck or Yamato. Even older traces rest deeper. Volcanic islands rise and fall over millennia, drowning civilizations whose stories dissolved before language evolved. Legends of submerged cities in the Mediterranean may refer to real Bronze Age towns crushed by quakes and tsunamis before writing existed. What humans call myth is sometimes erosion disguised as memory. As waters rise today, modern ruins join the archive. Coastal roads collapse into surf, cemeteries flood, coffins lifting like driftwood. Apartment complexes in places like North Carolina and Louisiana vanish foundation first, returning occupants to higher ground and leaving skeletons of steel and concrete for storms to finish. Time-lapse footage doesn't capture the insult, just the inevitability. Some scientists talk about future underwater archaeology before the present is even done building its own wreckage. If the ocean keeps advancing at 1 meter per century, entire neighborhoods, ports, and resort towns will end up as reefs. The luxury condos of today could be the scuba destinations of the next age, colonized by coral and fish who don't care what the HOA once charged. Nothing humanity leaves stays gone. It sinks, rusts, calcifies, and becomes habitat. The ocean never wastes material, it repurposes it. And one day, long after the last historian stops writing, something will swim past our collapse and not know it was ever anything but reef. The ocean doesn't just hold life, it engineers it in forms that look impossible until they're real. Every depth, temperature, chemical mix, and pressure zone writes its own rules, and evolution answers with designs humans wouldn't sketch on their wildest day. What survives underwater isn't random. It's precision sculpted by environments that don't tolerate error. In coral reefs, survival is speed and disguise. Parrotfish sleep in mucus cocoons to hide their scent from predators. Octopuses vanish into rock by changing color, texture, and even posture in under a second. Stonefish bury themselves in sand with only toxin-loaded spines exposed. perfectly still, perfectly lethal. Cleaner wrasses run small businesses, picking parasites off client fish who line up like customers. Clownfish live in venomous anemones because their mucus disguises them as locals. In the open ocean, survival is endurance and shape. Tuna and swordfish cruise with bodies built like torpedoes, blood heated by countercurrent systems that give them speed even in cold water. Sailfish slice through schools with bills sharp enough to wound prey mid-strike. Mahi-mahi flash neon colors when feeding, signaling aggression or frenzy in wavelengths predators misread until it's too late. Near the surface at night, vertical migration turns the sea into a reverse avalanche. Lanternfish, bristlemouths, and zooplankton rise from the deep to feed where light once ruled. They ascend in numbers so massive the layer shows up on sonar like a false seafloor. Before sunrise, they sink again to avoid becoming breakfast. It's the largest daily movement of life on the planet, and most humans haven't heard of it. In the deep sea, survival is adaptation to darkness and hunger. The gulper eel can unhinge its mouth to swallow prey larger than itself. The fangtooth fish carries teeth so long it has slots in its skull to close its jaw. Vampire squid drift with minimal movement, using filaments to sense snacks in the dark while conserving every calorie. Anglerfish females grow large and keep bioluminescent lures. Males are tiny parasites that fuse to them, becoming permanent sperm-producing appendages. At hydrothermal vents, life ignores sunlight altogether. Tube worms grow taller than people with no mouths or digestive tracts, feeding entirely through symbiotic bacteria living inside them. Rimicaris exoculata shrimp cluster around 700-degree vent fluid, farming heat-loving microbes on their shells. Pompeii worms survive temperatures that would melt most tissue, with their backs covered in bacteria that act like flexible armor. Even microbial life does things that look like science fiction. Bacteria in methane seeps consume hydrocarbons with efficiency oil companies envy. Extremophiles in subglacial lakes metabolize minerals in total darkness. Some archaea breathe sulfur or metal ions instead of oxygen. Viruses in the ocean outnumber stars in the universe and help regulate plankton populations without ever appearing in a nature documentary. On the seafloor, giant isopods scuttle like armored cockroaches the size of puppies, scavenging whale corpses. Basket stars unfurl fractal arms to catch floating food. Sea cucumbers eject their internal organs when threatened, growing them back later like it's routine. Dumbo octopuses glide on ear-like fins, their gelatin bodies built for low energy drifting in depths where pressure would crush submarines. Even ecosystems exist inside ecosystems. Whale falls create entire cities of bone-eating worms, hagfish, snails, and microbes that can live off a single carcass for decades. Kelp forests shelter sea otters that keep urchin populations in check, preventing them from mowing down the algae that produces oxygen and habitat. Seagrass meadows host seahorses, pipefish, and juvenile fish that would never survive open water. Life isn't rare in the ocean, it's relentless. It fills every crack, trench, vent, current, and twilight that allows even a sliver of chance. It doesn't wait for permission. It arrives, adapts, and evolves until the environment says no. And even then, something else takes its place. Humans keep trying to understand the ocean with surface logic, but the technology they build is always playing catch-up to conditions that don't negotiate. Ships, satellites, subs, sensors, and cables stretch across and into the water like stitches on a wound that never closes. Every breakthrough reveals more mystery, not mastery. Satellites can scan sea surface temperatures, track chlorophyll blooms, and detect sea level rise within millimeters. They watch currents like arteries and storms like infections. But they can't see through the first skin of water. Below the surface, they rely on inference, gravity mapping, radar bounce, and color distortion. The deepest seamounts, canyons and trenches show up as shadows in math, not images. Sonar does the heavy lifting where light fails. Multi-beam echo sounders map the seafloor by blasting sound downward and measuring return time. Most of the maps that exist were made during naval operations, not research. The gaps are colossal. Entire mountain ranges underwater remain nameless. In some places, the depth recorded on charts is just a question mark or a number guessed decades ago. Autonomous underwater vehicles roam the deep with sensors, cameras, samplers, and lights, but they move slowly and risk being lost to pressure, currents, or terrain. ROVs tethered to ships capture footage and collect specimens, but one bad move and a manipulator arm snaps off, or a thruster dies in mud that hasn't seen daylight in millions of years. Fiber optic cables snake across the seafloor, carrying nearly all the world's internet traffic. They rest on plains, drape over canyons, and lie beneath storms, quakes, and landslides without fanfare. They can break from anchors, landslides, or sharks, mistaking electromagnetic signals for prey. When they snap, communication blips ripple continents apart. Even listening devices have double lives. Hydrophones record the songs of whales, the crackle of shrimp, the groan of icebergs, and the rumbles of underwater quakes. But many of the arrays were built for military surveillance to track submarines during the Cold War. Scientists only got access later, inheriting a library of sounds that includes unknown clicks, hums, booms, and groans without confirmed origin. Submarines slip through thermal layers where sonar bends and hides them. Nuclear subs can stay underwater for months, traveling thousands of miles without surfacing, their only limitation being food and human nerves. The ocean swallows their paths and noise. Lost ones become graves, with coordinates classified or forgotten. Climate scientists deploy Argo floats, thousands of autonomous probes that drift with currents, dive to 2,000 meters, collect data, then surface to transmit it. They've built the most detailed picture humanity has of how the upper ocean is changing. But the deep beyond that is still dark. A new generation of floats pushes deeper, but deployment is slow and coverage is sparse. Mining drones and deep-sea extractors are the next wave, machines designed to vacuum nodules, scrape crusts, or drill vents. They claim they'll work surgically, but no one believes a billion-dollar industry plans to tiptoe through ecosystems older than mammals. The ocean won't stop them. Only regulation or collapse will. Even our waste travels with technology. Lost shipping containers spill into the sea and open like steel eggs. Fishing nets drift as ghost traps for decades. Oil pipelines rupture under unseen pressure points. When storms drag debris into trenches, it doesn't return. Human trash has reached the deepest point on Earth. A plastic bag and candy wrappers photographed in the Mariana Trench like punchlines no one laughs at. For all the tech humans send into the ocean, they get back fragments, sound bites, snapshots, samples, telemetry, like postcards from a world that doesn't want visitors. The more they push, the clearer it becomes. The ocean is not behind, it's beyond. Every story told about the ocean is shaped by what little humans witness, not by what actually happens. Most of its events occur unseen, undocumented, and unapologetic. The surface is theatre, the depths are reality. Storms don't need an audience to tear open currents. Earthquakes don't need cameras to trigger tsunamis. Creatures evolve, hunt, migrate, and vanish without ever existing in a textbook. Underwater volcanoes erupt more often than those on land. Most of the planet's volcanic activity happens along mid-ocean ridges where magma rises through cracks and solidifies into new crust. Lava meets cold water and hardens into glassy pillows stacked over thousands of miles. Whole mountain chains form without anyone noticing. Scientists only started detecting eruptions by listening for tremors and hydrothermal changes that ride currents up like whispers through boiling black. Tsunamis don't roar, they glide until it's time to rise. In deep water, they travel at jet speed, 500 miles per hour, with waves only a few feet high. No one sees them coming except satellites or buoys. When the seafloor shifts, the ocean transmits the force across basins like a message wrapped in silence. It only stands up when land tells it to. By then, it's too late for anything slower than instinct. Quakes beneath the ocean floor reshape coastlines faster than erosion ever could. The Boxing Day earthquake of 2004 rearranged the Indian Ocean in minutes, triggering a tsunami that killed over 200,000 people across 14 countries. But the rupture itself happened in darkness, where tectonic plates grind under miles of water and sediment without witness, without pause. The deep also hoards storms of its own. Internal waves, massive, slow-moving underwater equivalents of surface swells, roll along density layers hundreds of feet tall, invisible from above. They transport heat, nutrients and energy across ocean basins. Submarines feel them like elevators made of water. Most ships don't even know they exist. Landslides beneath the sea collapse with more force than anything on land. Sediment cliffs crumble and trigger turbidity currents, avalanches of sand and mud that travel for hundreds of miles across the seafloor, burying everything in their path. One ancient slide off Norway, the Storegga event, created tsunamis that hit Scotland with waves up to 80 feet high. No myth recorded it, but peat beds, shells and debris tell the story. Even methane lies in wait under pressure, trapped in crystalline hydrates that look like ice but burn when lit. If temperatures rise or currents shift, those hydrates can destabilize, releasing gas in plumes that alter buoyancy and feed microbial blooms. Some scientists think ancient climate shifts were triggered by sudden oceanic methane release, greenhouse bombs with no warning label. Entire ecosystems rearrange themselves without input. A volcano can birth a new island overnight, only for waves to strip it away in days. A reef can die in a season and take 1 million species homes with it. A current can shift, and migration routes that existed for 50,000 years collapse in a single decade. Humans call these changes. The ocean calls them process. And then there are the unknowns, the sounds, shapes, signals and sightings no one can classify. Sonar picks up pings with no origin. Cameras record silhouettes vanishing into blackness before they're focused. Acoustic anomalies are logged and filed under unidentified. Some scientists joke about sea cryptids. Others don't joke at all. The ocean doesn't need to hide its secrets. Its conditions do that naturally. Darkness, cold, pressure, depth, and distance erase evidence before discovery begins. Most of Earth's past, present, and future lies submerged and uninterested in being explained. For all the scars humans leave on the ocean, some of the strangest damage happens invisibly. Pollution isn't always dramatic. Sometimes it's microscopic, chemical, or slow enough that people don't notice until the consequences show up in their lungs, food, or coastline. The ocean absorbs everything thrown at it. But absorption isn't forgiveness. It's redistribution. Plastic isn't floating in one place. It's shredded into invisibility. Sunlight, salt, and friction grind bottles, wrappers, ropes, and tires into fragments smaller than sand. These microplastics drift through surface currents, sink into trenches, freeze into Arctic ice, and fall with snow in the Alps. Fish eat them. Whales filter them. Humans inhale them and drink them in tap water. Autopsies on seabirds and turtles reveal guts packed with lighters, caps, bags, and straws. But that's only the visible fraction. The rest hides in plankton, larvae, and sediment. Oil spills make headlines only when they coat beaches, but most petroleum enters through runoff, tank cleaning, and leaking infrastructure. It travels in thin films that block oxygen exchange at the surface and kill eggs, larvae, and microorganisms before they grow into anything humans value. Dispersants used to clean up brake oil into droplets that sink into the water column, poisoning life in layers nobody monitors. Chemical runoff from farms and factories flows through rivers into the sea, feeding algae that bloom explosively and die off, consuming oxygen as they decay. The Gulf of Mexico hosts a hypoxic dead zone every summer, where fish flee and bottom dwellers suffocate. Similar dead zones appear in the Baltic Sea, Arabian Sea, Chesapeake Bay, and off China's coast, areas where the water looks normal but can't support breath. Radiation hasn't stayed on land either. Waste from past nuclear tests, discarded barrels, and reactor leaks sinks or spreads through currents. Deep trenches hide canisters dumped by militaries decades ago. The ocean dilutes, but it doesn't erase. Particles persist in bone tissue, shell layers, and organisms at the base of the food chain. Noise pollution shreds communication in species that rely on frequency and rhythm more than sight. Sonar bursts rupture organs and shatter inner ears. Ship engines create endless bass tones that mask navigation. Seismic blasts hammer the seafloor at intervals like a metronome of disruption. Some animals adapt by calling louder or changing frequency. Others go silent and vanish from areas they once ruled. Light pollution along coasts disorients hatchling turtles, seabirds, and fish larvae that rely on faint moonlight and horizon glow to navigate. Artificial brightness pulls them inland, where they die in drains, on roads, or in the mouths of predators that learn to follow the glow. Even carbon emissions don't stay in the air, they dissolve. Ocean acidification is invisible but relentless. When carbon dioxide mixes with seawater, it forms carbonic acid, lowering pH and dissolving shells, skeletons, and coral frameworks. Plankton with calcium carbonate structures thin out. Shellfish struggle to form armor. Reefs crumble from the inside. The chemistry that once supported life becomes corrosive 1 decimal point at a time. Heavy metals like mercury and lead leach into water from industry and mining. They bind to fatty tissues and climb the food chain. Tuna, swordfish, and marine mammals accumulate enough toxin to poison whatever eats them, including people. Top predators become storage tanks for everything the water collects. Even sunscreen chemicals wash off swimmers and tourists into reefs, bleaching corals and disrupting reproduction. The ocean receives tourist runoff like rain receives ash, quietly, constantly, cumulatively. The damage humans cause doesn't always float, stick, or roar. Most of it sinks, dissolves, scatters, or hides. The ocean takes it in because that's what it does with everything. But it always sends the bill back in hunger, collapse, disease, storm, or silence. The ocean doesn't move in straight lines or follow the logic of maps. Its currents are highways, barriers, engines, and memory systems wrapped into motion. They decide where heat goes, where life thrives, and where storms are born. Without them, the planet would cook in one hemisphere and freeze in the other. The water doesn't flow randomly. It circulates like blood through a body too massive to monitor. Surface currents follow wind, Earth's rotation, and the shape of continents. The Gulf Stream drags warm water from the tropics to the North Atlantic, making winters in Europe survivable. Without it, London would feel like Labrador and Paris would freeze like Quebec. The Kuroshio Current does the same for Japan and the Pacific Rim, feeding storms and fisheries along the way. The Humboldt Current pulls cold, nutrient-rich water up the coast of South America, supporting anchovy populations so massive they reshape economies and ecosystems. Gyres, the massive rotating systems in each ocean basin, trap everything that floats. They sort plankton, larvae, jellyfish, plastic, and debris into spirals that can take a decade to complete a loop. The North Pacific Gyre is famous for the garbage patch, but the trash isn't an island. It's a soup of particles and forgotten objects riding a conveyor belt with no destination except fragmentation. Beneath the surface, currents follow temperature and salt. Cold, dense water sinks in the polar regions and crawls along the seafloor toward the equator. Warm surface water evaporates, leaving saltier, denser layers that drop and push circulation forward. This global loop, thermohaline circulation, moves heat and nutrients through all the world's oceans. It's slow, ancient, and critical. One disruption can rewrite climates across continents. Upwelling zones haul cold water upward where wind pushes surface water away. That deep water brings nutrients from the bodies of long-dead plankton and fish, feeding blooms that attract whales, seabirds, and fisheries. Where upwelling fails, coastlines starve. Where it thrives, life stacks itself in layers. Internal tides move through the deep like invisible tsunamis, cycling energy through density layers no eye can see. They can be taller than skyscrapers and run for hundreds of miles, but only instruments feel them. They churn nutrients, shape trenches, and push animals up and down the water column like elevators designed by gravity and temperature. Storms feed on the currents whether humans track them or not. Hurricanes spin up over warm water, stealing energy and moisture until they become machines of wind and tide. Currents steer them like conveyor belts. A storm born near Cape Verde can cross an entire ocean, strike a coast, and still carry the heat it gathered weeks earlier. Without currents, storms would die before making landfall. With them, disaster becomes exportable. Currents also carry migrants and invaders. Larval fish drift into new ecosystems and change food webs before anyone sees them coming. Jellyfish blooms ride eddies into coasts, shutting down power plants and overwhelming beaches. Lionfish, carried by ballast water or pet owners, now swarm the Atlantic and Caribbean, consuming native fish faster than reefs can recover. The water doesn't care about native or invasive, only viable and not. Even oxygen follows the current. When circulation slows, dead zones swell and spread. Warm, stratified water holds less oxygen and mixes less. Fish flee upward or suffocate. Coral reefs bleach faster. Deep zones lose their breath. Carbon stays locked in shallow water instead of sinking. If the thermohaline engine collapses or slows too much, the consequences don't announce themselves. They unfold. Storm tracks shift, monsoons weaken or intensify, heat domes stall over land, seas rise faster at some coasts and retreat at others. Ice melts from beneath instead of above. Fisheries collapse as plankton distribution snaps out of sync. Currents are motion disguised as stability. They're history disguised as weather. They don't ask for direction, they give it. And nothing on land outruns what they decide to move, feed, starve, or drown. The creatures humans fear in the ocean aren't always the ones that deserve it. Sharks get painted as villains, but they're maintenance workers cleaning up the sick, the weak, and the unlucky. Meanwhile, the real horrors are often translucent, slow, silent, or too small to Instagram. The ocean builds monsters in sizes large and microscopic, and fear doesn't always scale with mass. Sharks have survived 5 mass extinctions and hundreds of millions of years of planetary mood swings. Their skeletons are cartilage. Their teeth grow in conveyor belts. Some give live birth, others lay leathery egg cases called mermaids' purses. The Greenland shark can live over 400 years, moving slower than a yawn, but carrying history in its flesh. Great whites can smell a drop of blood in an Olympic pool and accelerate like missiles, but they don't hunt humans on purpose. Most bites are test nibbles from animals older than every country that exists. The box jellyfish, on the other hand, kills faster than most weapons. Its tentacles fire nematocysts loaded with venom that stops hearts and paralyzes lungs. Some victims drown before they feel the sting. And it's almost invisible in the water, drifting close to shore where swimmers never expect assassination by gelatin. Cone snails look like shells tourists collect, but they shoot harpoons loaded with neurotoxins that shut down muscles instantly. There's no antivenom for many species. One sting can end a life before the snail finishes retracting its weapon. Blue-ringed octopuses wear their warning signs like jewelry, glowing rings that pulse when they're annoyed. Their venom contains tetrodotoxin, strong enough to kill dozens of humans in minutes. They're the size of a golf ball and hide in tide pools where children play. Even plankton can destroy without trying. Certain algae release toxins that build up in shellfish, poisoning any mammal that eats them. Red tides stain the water with death and choke coasts with foam and fish corpses. Some blooms produce gases that irritate lungs miles away from shore, turning beaches into chemical zones without flames. The Portuguese man-o'-war isn't one creature, but a colony of polyps acting as one organism. Its tentacles can reach 100 feet and still sting after detaching or washing ashore. It floats like a balloon with venomous threads trailing, catching fish and unlucky swimmers with the same indifference. Sea snakes hold some of the most potent venom on Earth, but their fangs are tiny and their bites often painless until paralysis sets in. They swim with flattened tails like living ribbons and surface for air between dives that can last hours. Fishermen sometimes pull them up in nets without realizing they're holding death by the tail. Even the seemingly harmless has teeth. Sea urchins lodge spines deep in skin that break off and fester. Stonefish deliver venom through dorsal spines that feel like being set on fire from the bone out. Moray eels lunge from crevices with second jaws that shoot forward like a horror prop. But the biggest hunters aren't always predators. Orcas can take down great whites with coordinated tactics, ramming and flipping them to induce tonic immobility before eating only the liver. Sperm whales dive miles down to battle colossal squid, returning with sucker scars the size of dinner plates. Leopard seals patrol Antarctic waters hunting penguins with methods that look almost playful until the blood spreads. And somewhere in the dark, colossal squids drift with eyes the size of dinner plates and tentacles lined with serrated hooks. They don't seek ships or stories. They exist in silence, unknown to most of the species sharing the planet with them. Fear of the ocean is earned, but it's rarely accurate. The things worth fearing don't stalk, they wait. They don't roar, they pulse, drift, hide and strike when curiosity or arrogance gets too close.